Recording has started.
I am pleased to welcome you to the launch of the Fab Academy 2019 cycle. We have 104 sites connected right now. And I'm extra pleased for a few reasons to be joining you. One reason is, I haven't transferred this yet. Right now, I'm setting up this lab with a picture from minutes ago. And in the screen share, you can see where I am in Puerto Williams. And then if we zoom out, it's Cabo de Hornos and Isle Navarino. And then it's at the bottom tip of Chile. And it's the southernmost city on Earth. And so we're setting up a lab looking at use of natural resources and sustainability at the end of the longest supply chains at the southernmost city. The last thing after here is Antarctica. And internet is difficult here, but they were able to pull together enough connectivity for me to join you from here. So I'm particularly excited. And I think it's an interesting moment for the Fab Academy to have the first class go to the world from the bottom of the earth. So greetings from the bottom of South America. So this is the first Fab Academy class. And what we're going to do in this class is I'm going to give about a 1-hour lecture on what is digital fabrication. What is Fab Academy? What are Fab Labs? What is all of this about? I'll talk a bit through the structure of the cycle of the Fab Academy. Then we're going to hear a few final presentations from the last cycle, and that'll take us up to an hour and a half. Then we'll have a 15-minute biology break. And then after the bio break, we'll do a really fun thing, which is at about a minute per lab, we're going to go around the world and meet everybody connected. After this, we slow down, and during the Q&A, we meet people individually, but we'll do this high-speed world tour. Okay, so that's what's going to happen today. And then in the succeeding weeks, there'll be a rhythm where the first half of class reviews work with the new capability we've covered, and then the second half of class is the new unit. And so I'll talk through, after my introduction, in more detail, the schedule of what we're going to be covering in this agenda. Now, for the introduction I'm about to do, I'm pleased to be joined by, let me go back to the beginning. Yeah. I recently wrote a book with two people who happen to be my brothers. Joel was the Dean of Labor at the University of Illinois and ran the Industrial Labor Relations Association and is a guru on the future of work. So, hi, Joel.
Hi, delighted to be online.
And then Alan breaks technology. Alan ran the biggest, developed and ran the biggest video game studio, Activision, and now leads Eline Media that does video games for education and social change. So, hi, Alan.
Hello.
And then this book came about because I would talk about what I'm about to talk about, and Joel and Alan would believe me in the technology, but they would groan about how naive I was about the social consequences of technology in society, I think it's fair to say. And
That's
that
fair.
Conversation grew, that's fair. That conversation grew into writing this book. And so I invited them doubly, both to be a backup if I can't connect from the bottom of Chile, but also to listen into the introduction and to join in as we go through talking about what this is all about. So I invite them to point out where they think I've gone off the rails. So here we go. The goal of this is, this is a bit different from the very interactive format of classes. This will really be a tour through history of digital fabrication. What is it? What are Fab Labs? And where is all this going? And so we're gathered here around a digital revolution. We had one in communication. We had one in computation. We're having one now in fabrication. And I'm just getting ready with my mobile notes. Keeping track of the capacity. So to understand where this is heading, this is the most, I'd say, important graph in history. Gordon Moore wrote a wonderful paper where he plotted the number of transistors on an integrated circuit, and he saw that they were doubling. On a linear plot, it was looked like nothing was happening. Excuse me. If you take the logarithm, it's a straight line. And he said, what if this continues for 10 years? And he foresaw in this beautiful article a lot of what happened in the digital revolution. The one thing he got wrong was it wasn't 10 years, it was 50 years. This is 50 years of what became called Moore's Law. And so on a linear graph, it looks like nothing's happening and there's a revolution. But on a logarithmic graph that measures doubling, it just lines up in a straight line. So all the way back in 1952, Gordon Moore could really predict the next 50 years of the arrival of digital computation and communication. So Sherry Lassiter, who runs the Fab Foundation, and many of the people in the Fab Lab network know, noticed a first few points in the number of Fab Labs. And so for this book, I gathered the data. This is the number of Fab Labs. And for 10 years, they've been doubling every year and a half. We didn't plan that, and I'll talk much more about how it happened. And so on a linear graph, it looks like there's a revolution happening. On a log graph, it's just a straight line. And so one way to understand what this is all about is, what if this continues for 50 years? So for 50 years, digital fabrication scales in the way communication and computation did. But a lot was exciting, and a lot of problems also came, excuse me, from digitization. And so we have a chance now to really look ahead to the next 50 years of the scaling of digital fabrication and get that right. So here's data point number one. At MIT in 1952, a computer controlling a machine to make something was invented. So this is the birth of connecting early computers with computer-controlled machines. And so what was happening at the time was this was, at MIT, the Whirlwind, the first real-time computer. And then jet aircraft were emerging that needed parts that were too hard to make by hand. And so there was this idea that you could connect a computer that had nothing to do with a machine to a machine to make a part. So that was the birth of computerized machining. At the same time, Vannevar Bush at MIT was making the last analog computers. And they were analog, which meant they got worse with time. They were rooms full of gears and pulleys. And so Claude Shannon wrote a beautiful master's thesis where he introduced digital logic to, and then he and von Neumann applied that to computing and communication. And the heart of what they showed was by computing and communicating with symbols, you can have an unreliable connection but communicate reliably. So my message to you is going by microwave from Puerto Williams, Chile to Oshio, Argentina, and then through a series of hops. And each of those are noisy and imperfect, but the result you get from it is reliable. Now, that idea in fabrication is actually, depending on how you count, 4 billion years old. 4 billion years ago is when life evolved the molecular assemblers that build us. And you're actually built with a code. A molecular machine called the ribosome reads a code and assembles molecular Lego called amino acids. And it does all the things a digital computer and a digital communication taught us, but it uses you to construct. And so the research program I run at MIT, the Center for Bits and Atoms, was started to look at how digital communication and computation relates to fabrication, not just digitizing designs, but actually digitizing the materials themselves. And as we go ahead, I'll talk about the research behind that. To do that research, where we've done things like make in the lab quantum computers or molecular machinery, we assembled research tools to make anything of any size for the research. And then to teach people to use it, it would take a lifetime of classes. So I started a class at MIT called How to Make Almost Anything, just to learn to use the tools, and wasn't prepared when like hundreds of students would show up to take the class. And they did the most amazing things. Kelly made a device that saves up screams and plays the scream back later when it's convenient. And this is a web browser for parrots. And this is an alarm clock you wrestle with and prove you're awake. And this is a dress instrumented with sensors and spines. And if you come too close, the dress defends your personal space. And so these amazing things would happen year after year. And that's when I realized that the students in this class were answering a question. Felicity, Fab Lab Winam, you need to mute, and if not a moderator, can you mute Felicity? The students were answering a question I didn't ask. I was asking how to do digital fabrication, but not why. And they were showing the killer app for digital fabrication is personal fabrication. So in the computing history, the big whirlwind computer was transistorized as the TX. That was commercialized as the PDP. The PDP was used to create the internet. And the person behind that company famously said, you don't need a computer at home. And the whole mini computer industry failed. It was bankrupted by the arrival of personal computers. And so in the same way, digital fabrication enables personal fabrication, which isn't production for a mass market, but it's production all the way down for a market of one person. And so there's a natural kind of hierarchy of the $1 million research tools we use in the lab, and then supporting those are $100,000 workshop tools to develop what happens in the $1 million tool. And then within those are the $10,000 tools we use to make things that can make $1,000 machines, that can make $100 machines. And that kind of parallel led to the idea of Fab Labs. So again, in 1952, there was one numerically controlled milling machine. Today, there's about 1,000 Fab Labs. Actually, the number last I checked was 1,600. And 1,600 is an interesting number because that's roughly the number of cities on Earth. So there's one Fab Lab per city today. And so this, I won't play it now, but this is a video made by Bob Dylan's son, Jesse, that introduces it. This is a Fab Lab. Frosty, are you connected from Vestmannaeyr? This is a Fab Lab in Vestmannaeyr, Iceland, a little volcanic island off the coast of Iceland. And this is a fully equipped Fab Lab as it exists today. It's about a $100,000 investment. It's about 2 tons of stuff. It includes a 3D printer, but it includes all these other tools that you'll be learning in class. And so with those tools, you can do this. You can make boats, bicycles, furniture, houses, antennas, radios, consumer electronics, healthcare sensors, production tooling. Everything you see here wasn't made in my lab at MIT. It wasn't made by a company. It was made by people in Fab Labs using the tools you'll be learning. And so they started to spread. Håkon was a herder in North Norway, and Kalbag was a pioneer in rural India. And Vigyan Ashram, I know, is connected today. Mel King was a pioneering activist and community activist in Boston. And each of them pulled these labs into their communities, seeing the impact of digital fabrication. Let's see, Rania, you need to mute. And so this is the current Fab Lab map. Again, there's about 1,600. Nobody planned this, but they've been doubling every year and a half. Just to show some of them, Blair, I believe you're on in Detroit. Among other things, he's been working with at-risk youth. We'll meet all of these people after the break when we go around the world. Yeah, Rania, again, you need to mute if one of the moderators can mute Rania. This is a lab done with Alaska Natives, the Cook Inlet Tribal Council, where there's wonderful cultural traditions, but also serious issues with alcoholism and unemployment and suicide, working about merging traditional crafts with modern digital fabrication. This is one at a beautiful arts colony in Maine, merging traditional craft with modern digital fabrication. This is one in Bhutan. This is the Prime Minister of Bhutan looking at sustainability in a very traditional, beautiful Buddhist country, focused not on gross domestic product, but on gross national happiness. Instructors, we're at 122 connections. Please keep an eye on adding people at this point. We're close to this conference capacity. This is a developing floating fab lab in the Amazon. This is one at Protestant Catholic boundary in Northern Ireland. This is one in Holon, Israel. And each of these labs has the same capabilities. So people and projects are merged across them so they can really function as a network. And we'll meet many of them after the break. Many of the ones I showed you are connected today.
She told me if we build it, we do it.
So to understand the Fab Academy, we had a problem. This is Hans Christian, who was considered a problem in the local school in North Norway because he knew everything they were teaching, and I showed him some projects, and the next time I saw him, he was making robot vehicles in the lab. And this was Chapiso and Soshengovi, outside Pretoria, doing the work of my classes at MIT in the lab. And they would fall off an educational cliff. They'd have to leave. And so the Fab Academy emerged to teach the skills of digital fabrication. Let's see. The first class or so takes some practice for video conferencing. Richard, that's you. The Fab Academy emerged with a very different model. Instead of going to a central site or looking at an online class, this is distributed where each of you are students with peers and mentors in work groups with local machines, and then you're connected globally with video and content sharing. So this works like the internet, not the bitnet. And so you each are going to do a final project. This is a great example. This was a green Fab Lab outside Barcelona, and this was Guillaume's project. He was interested in food. So at the beginning, he could make a sketch of an aquaponics system. Then he learned the CAD tools, and so he could start designing it. Then he could do large format machining and start to make a full-size version. Then he could start to instrument it. Then around here, he's learning to make the electronics. So this is an Aquaduino he developed. And again, you'll learn to do all of this. And then I love this picture. Around week 16, he's eating the lettuce produced from it. And this prompted a whole Aqua Pioneers collaboration. And so this wasn't a startup. It's not a business. It could be. But this was one person mastering all of these skills to make this aquaponic system. And you'll be learning how to do everything you saw in that video. So it spawned a number of projects like these, drones, furniture, citizen science, spawned a job board, other classes. There's a Bio Academy roughly where Fab Labs develop biolabs that teach biotechnology. There's a very lively Fab Academy teaching textile technologies. And all of this, the name was sort of a joke, but became Academeni, the Academy of Almost Anything, using this global campus. And so you can think of MIT, it's like a mainframe. You go there for processing. Online classes are like time sharing. And this is like the internet. It's an educational network. It's collaborative and distributed. So as the labs grew, they started gathering. Local check to make sure everything's okay. A few years back, the whole lab network came to Barcelona. And a really interesting thing happened there, which is Barcelona has a great design tradition and over 50% youth unemployment, serious economic issues. And so the Barcelona Fab Lab, one of the founders, Vicente Gallart, became the city architect, and one of his colleagues became the mayor, Trias. And this is a moment where Mayor Trias is pushing a button to start a 40-year countdown to urban self-sufficiency. The idea is instead of products coming in and trash going out, let's see. I'm pausing because my video is frozen.
But your voice is still coming through.
Okay, do you hear me?
Yes.
Okay, good. I'll keep going then. My incoming video was frozen. Maybe it's too cold for the data here. But if my audio is fine, I'll keep going. So he started a 40-year countdown to urban self-sufficiency, to cities being able to produce what they consume. And that's grown into a Fab City initiative. Now, all these cities around the world are part of this collaboration where instead of global supply chains and then jobs to get money, to get work, to get products, you have the means to produce as part of urban infrastructure in this Fab City initiative. And now they're remaking a whole district in Barcelona around Poblenou as a Fab City prototype. This was a lab we ran at the White House in the Obama administration that inspired legislation in the US for universal access to digital fabrication in the same way we have universal access to communication and computation. We've worked with humanitarian groups on a global humanitarian lab to deliver relief, not by sending solutions, but by sending the means to create the solutions. This meeting has progressed from Fab 11 at MIT, Fab 12 was hosted in Shenzhen, Fab 13 in Chile, where I am now, Fab 14 in France, Fab 15 is coming in Egypt, Fab 16 will be in Canada, and Fab 17 in Bhutan. And it's a wonderful event. And so when you finish the Fab Academy, the graduation is held at this global gathering. To support all of that, we've spun off a Fab Foundation. And the way to understand all of that is the technology of the internet has radically changed, but the organizations that grew up around it still are here today. And in the same way, Fab Academy and Foundation and all of these are building the organizational capacity. If anybody can make anything anywhere, how do you live, learn, work, and play? The capacity for all of that. So I'm going to pause here. I'm about to talk about now the technical scaling. But Joel and Alan, do you want to chime in on anything?
Yeah, I'll go first and Alan will join in. We'll each make just a few comments, which is, I guess, our prerogative as your brother. I'll share three thoughts, one very positive and enthusiastic, and two that are cautionary. So, as Neil indicated, my expertise is in the workplace and in some ways the future of work. And what I'm going to say that's very positive is that the idea of people being able to make what they need and break a dependence on global supply chains to be locally self-sufficient but globally connected totally redefines our conception of work. Because for more than 2 centuries, the ownership of the means of production required the accumulation of capital and successively
저희 아빠가
larger.
그 때문에 계속 좀
Hello?
수십 년간을
Somebody.
계속 영화 볼 때나 이런 데도 그 진짜
That was Young Woo Song, who I just muted. Go ahead, Joel. Joel, you go ahead. Oh, Joel, you're muted now.
The prospects of digital fabrication allowing this local self-sufficiency fundamentally changes our conception of work itself, and it's very exciting. Having said that, I'm going to give 2 cautionary notes. The first is that you, as students in the Fab Academy, are part of an ecosystem. And ecosystems have organizations and are really what we call an institutional arrangement. And institutions need to do 2 things. They need to create value, and they need to mitigate harm. And right now, you are part of a system in which the value proposition has to do with your learning skills and knowledge, digital and design literacy, in order to be part of this growing movement of capability. But to put it simply, the Fab Charter and the other means for governance in this ecosystem do not match the full needs that it has. And so my first message to you is that you have agency as part of this system to speak up when the system doesn't respond to concerns or questions that you have, because the way in which things are decided and governed is not robust given the scale at which things are growing. And part of the way to shape that is to act on it. And so, you know, if I were to teach a course in Academy, it would be how to govern almost anything. And the first application would be the Fab ecosystem. The second thing, by way of a cautionary note, is mitigating harm is actually a very serious issue. And I would say that 95% of the energy in the Fab ecosystem goes to creating value. And there's a little bit about safety and security in a Fab lab. But as you get larger, the risks that are out there that we need to worry about will grow. And the ability of this whole system at the Fab level, at the regional level, and at the global level to have mechanisms to identify risk and to mitigate harm needs attention. So one vote of enthusiasm that you're part of increasing self-sufficiency in the world, and it's an exciting redefinition of work. And 2 cautionary notes that the way in which this ecosystem governs itself is a work in progress, and you have the agency to help shape it. And I want to particularly call attention to the ability to make sure that bad things don't happen. Let me turn it over to Alan.
Okay. Thank you, Joel. Alan?
Yeah, so just very briefly, in 1965, when Gordon Moore wrote his article, the concepts of digital access, digital literacy, enabling ecosystem, and risk mitigation actually didn't emerge for decades. When you look at just the concept of the digital divide, it showed up decades later. So one of the things that Joel and I want to stress is the idea of Fab access, Fab literacy, enabling ecosystem, and risk mitigation needs to be discussed now, and everybody on this conference is a key stakeholder. Neil mentioned in passing that we have in some ways he implied we've crossed the digital divide. We haven't. More than half the planet is not connected to the internet, and more than half of those that are connected are barely connected or marginally connected, and that creates huge divides. And just being connected is necessary but not sufficient. You need literacy on how to use these very powerful tools. So we have a unique opportunity right now. It's kind of like 1965 for Fab to really begin to think about what would it take to create universal Fab access? What would it create? What would it mean to have universal Fab literacy for those that have access? And I think everybody on this call who is going to become, in a sense, deeply literate in Fab is a key node in a network that can propagate, that can help foster access and literacy. So I'll just pause with those thoughts. And obviously, each one can be unpacked much, much deeper.
Okay. Thank you, Joel and Alan. Now I'm going to go ahead and look at the next 50 years. So after mini computers came hobbyist computers. This is the Altair. And you might not have heard of it, but a company called Micro-Soft started with it, and they eventually took the dash out. And the Homebrew Computer Club started with it, and eventually that became Apple. So a whole generation of pioneers started on this hobbyist computers. And those sold in the millions. And a million is interesting because that's the number of towns. So there was now one per town. And so the equivalent for that is today you buy a Fab Lab, but we're working very quickly towards Fab Labs making Fab Labs. So these are all Fab Lab machines made in Fab Labs. Like this is a fun one. This is a briefcase that you can take as carry-on luggage and has interchangeable heads, and you can mill with it, or you can print with it, or you can cut with it. And that was made by Nadia and Alan. And those spawned many products. So Alan started Shaper Tools, and another student, Max, started Form Labs, and HandyBots came out of this, and Fab Lights. These were products of Fab Tools that came from work on fabrication, but they were still like early computers in that you couldn't change them. And so what we really want is not just rapid prototyping, which this class covers, but rapid prototyping of rapid prototyping, being able to make the machines in the lab as easily as a project. And one of the things we'll introduce you to is machine building. And so from there, this is Nadia and James, who now runs research at Zahner that makes the architectural scale fabrication, like Frank Gehry's buildings. And now what they're doing is they're making modular machines, where instead of a machine having fixed parts, each part of the machine can move, it can compute, and it can communicate, and you can assemble them to snap together a machine to do all sorts of things rather than having a fixed machine. And the machine doesn't have a controller built into it, it's just a data network, and then you send messages in the network to teach the machine what to do, in this case, a hot wire cutter. And so that inspired Jens. I don't know if Jens is on in Oslo, but Jens toured the world. He's here with Obama's grandmother in Western Kenya. He started making versions of these modular machines with high-performance materials that you can make in the lab. So these are fab tools like the modular machines I showed you, but now just about everything here was made in the lab. And that inspired one of my current students, Jake, to extend that architecture. And so what you'll do later in the semester is start by designing a machine, where is it big or small or linear or rotary? Then how many degrees of freedom does it have? Then it'll make the cut files to make the parts of the machine. Then the machine, in a really interesting way I'll teach you, is a data network. So each motor, each sensor is a node in a network. And then you make a software graph that talks to the hardware graph. And so in this case, we were at an arts colony, Haystack that I mentioned, and they wanted to be able to print clay. And so Jake put all of this together. He added a little interface for designing pots, and then made a clay plotting machine. And the brains of the machine isn't built into the machine. It's built into this graph that controls it, that you'll learn about. So in that case, it's the clay, the very same things. This is a milling machine, this is a drawing machine, and this next one is a music playing machine. Playing a piece by Steve Wright called Music for Blocks of Wood. All of those were made from the very same parts, just arranging them in different ways, aiming for it to be easy, again, to make a machine as a project. And so what we call Fab 2.0 is the goal of you don't buy a Fab Lab, but you go to a Fab Lab to make a Fab Lab. And we're moving very quickly towards that.
So now, actually, I'm going to interrupt you for a minute. Neil has described with enthusiasm the machines that make machines, which you'll be learning about. And many of you may be techies like Neil who are just totally caught up in the mechanics. I want to suggest that with the machines that make machines, you need organizations and institutions that make organizations and institutions. And what I mean by that is that Jens didn't just come up with the idea that he did. He spent a year as an apprentice traveling around the world in different labs and built a sense of literacy, like Alan was describing. And should other people be doing journeys like Jens did? Is that part of the ecosystem? You know, if these machines can make machines, who makes the decisions about the machines that make machines? I'd like to prompt the handful of you out there who think about social systems while you're learning about the technology to be joining in as innovators on the social side.
It's a really great point that there isn't a central command and control office. Joel studies lateral networks, and this is a giant lateral network. And so machines that make machines need organizations that make organizations is a beautiful point he makes. Alan, anything before I go on?
Well, one small point just that's evocative on the positive side. There's a lot of press right now about the gig economy and how it's changing the future of work. The gig economy is only less than 1% of the sort of global workforce, but it's transformational because of the way it's growing. We're studying could self-sufficient work, not just at a personal fabrication, but at a community fabrication level. For most of humanity, communities made what they consumed at a personal, but also at a community level. And a lot of people are looking at the future of work in terms of jobs changed by technology, replaced or created, but very few people are looking at communities and individuals making what they consume as a meaningful part of the future of work. It provides great satisfaction. It has all sorts of benefits, but it's really hard. So what's the balance between pushing a button and ordering something from Amazon versus making something at a personal and community level? And this community is at the vanguard of making that, I think, aspirational component of the future of work possible.
Yeah, in fact,
I
want to reinforce it, even Neil, before you do, which is that a lot of the talk about how do we compensate people for the jobs that are lost misses the dignity and meaning of making things yourself.
Yeah, just to belabor what Alan and Joel's points, among the most defining issues today are trade, tariffs, jobs, employment, income inequality. And lurking here is really revisiting these fundamental assumptions about what is money, what is work. And you know, along with the technology you'll be learning is really the meta project of what does it mean to live, learn, work, and play in that world.
And again, a footnote. One of the classic concepts in economics is comparative advantage. And the idea is that companies get bigger because they're better at doing things. Nations get bigger or more important in the world economy because they have unique capabilities. At the community level, if people are making what they consume, there will be many comparative advantage. Some people are better at furniture. Some people are better at things that are programmed and so on. And that will require building out an ecosystem locally of barter and exchange. And so again, how you construct the social and economic system that goes with these capabilities and that can scale as the capabilities scale, because Neil's about to take us into a mind-boggling world of what's ahead, is the challenge.
And you'll hear more about this when I get to the schedule. We're going to have recitations in addition to the technical classes that'll talk about all of that. So to keep scaling, after the hobbyist computers came personal computers and then smartphones. And those got up to billions. And there's roughly one per person now. One of these computing devices per person on Earth. And there's a real scaling challenge. What's on the screen now that you can barely see is the inventory in a fab lab. And zoomed in is part of the inventory of electronic components. And so your labs have all of this stuff. You can make everything I said, but you need access to this whole inventory to do that. And we can't, when you get to one per person, you can't have all the delivery trucks bringing all these deliveries of all of these parts. And so the electronics vendor we use has hundreds of thousands of types of resistors or capacitors or inductors, but they just have a few material properties. They conduct or they insulate or they're semiconducting. And so we've started studying how you build electronics out of micro building blocks that you assemble out of a small set of parts, and then you send them to machines that aren't printers or cutters, but they're assemblers and disassemblers. So they take feedstocks of these micro parts and assemble them to build things like functional electronics and robots and all the rest of technology. We were studying that on tiny scales for circuits. On bigger scales, we're developing robots that assemble these parts to build things like aerostructures and spaceships. And then using those to make things like airplanes out of discretely assembled carbon fiber parts that can change shape to do large-scale space fabrication. And then finally, in computing and communication, we're in the Internet of Things era now. And we're scaling now towards on the order of 1 trillion computing devices. And to understand the number 1 trillion is 1,000 is a rough number for the number of things around a person. And so if 1 billion people each have 1,000 things, that's 1 trillion devices. And so if you look at the scaling, a smart thermostat has the power of the first mini computer. Not as a metaphor, very literally. And so computing went from 1 to 1,000 to 1 million to 1 billion to 1 trillion. And so if we look at that for fabrication, if you tried to get there by placing one part at a time, it would take millions of years to make anything, which is too long to wait. And so in biology, the way it does it is with a profound insight, which is the biological assembler called the ribosome. Let's see, I just paused again. Is my audio okay?
Yeah, audio's good.
The biological assembler called the ribosome is slow. It only places one molecule a second. You're made by placing one molecule in 1 second. But ribosomes make ribosomes, and so you can have trillions of them. And so that's led us to study not just machines that make machines, and not just assemblers, but assemblers that assemble assemblers out of their own parts. And so this, for example, is parts of a micro robot. This is about the size of a coin, made out of these little building blocks. And then this, in turn, is looking at how you make a machine that fabricates, and the machine can be made out of the same parts that it's fabricating with. And so this isn't a conventional machine. This is made out of a few types of building block parts to be able to make more machines. And we're working up to those machines making themselves. And then a whole bunch of things change at that point, because then to program it, you have to describe intelligence as geometry. The program becomes a structure you build into the construction. So you have to revisit how software works. Design tools change, because you have to design a machine that communicates a computation for its own construction. So you need to merge the design of communication, computation, and fabrication all into one tool. This was a fun... Alan's video game company did a fun version of a video game version of taking the research tools I showed you, but to make them easy to learn, each of these cartoon blocks is actually a physical property you can place. And then you can use it to design mechanisms, and then create worlds where they live. And so it's like Minecraft, but Minecraft with real physics. And starting to look at how you learn to design in this world of digitizing materials as well as designs. And so this was a prototype. We hope to be able to bring that out and make it widely accessible. Now, at the very beginning, and it might have sounded abstract, I introduced von Neumann and Turing. these pioneers in computing, the last thing they studied is fabrication. Von Neumann studied how a machine can communicate its own construction. And Turing studied how genes give rise to form, what's called morphogenesis. And so the pioneers in digital computing and communication ended their lives really studying how computation relates to fabrication. These questions we're leading up to. One way to understand that is this is a program I did for the movie The Martian on how you bootstrap a civilization. What are the minimum building blocks you need to create a whole civilization from scratch? It's like creating life in non-living material. And so stepping back, there's one Earth, 1,000 cities, 1 million towns, 1 billion people, 1 trillion things. Computing went from 1 to 1,000 to 1 million to 1 billion to 1 trillion, literally. And what I just gave you a tour of, there was one NC Mill in 1952. There's about 1,000 Fab Labs. We're just transitioning to the million machines making machines, to the billion assemblers, to the trillion self-assemblers. And so all of those exist today in various forms, but they're going to be emerging between now and 50 years from now. And so in this historical map, we're right at the transition from the mini computer to the hobbyist computer. And so all of you, in effect, are the Jobs and Gates of this new world, inventing Microsoft and Apple, but not likely with a very different notion about what is a business and what is a company, but right at this transition in this scaling roadmap. And so the book I mentioned I wrote with Joel and Alan is where I fill in the scaling roadmap technically, and then they explore the social implications. And if you don't have copies in your lab, we can send that out to any of the Fab Labs in the Fab Academy. And so that's a tour of what is digital fabrication, what is Fab Labs, and what does the next 50 years look like in scaling digital fabrication. And so in that, this is a class directly about how to learn the skills of digital fabrication today, how digital becomes physical, and around that to really prepare to tackle all of these opportunities and challenges about the future of work and infrastructure and society. And so in the class, let me now go to the schedule. There's a weekly cycle. Next week, I'm going to cover how you manage projects and web development and how you build the documentation in the class. The class after that is how you use computer tools to design things. Then we'll learn to use lasers and knives to cut things under computer control. Here you'll make a construction kit. Then we'll cover how to produce circuits, and you'll build a circuit board there that's a computer programmer. Then how to scan and print with 3D objects. Then designing electronics. This week is large format machining, how to make big things like furniture. This is how to write programs for little computer chips you build into your projects. Tooling to mold and cast to make production runs of parts. All sorts of sensors, all sorts of actuators like motors and displays. Then a class where we explore, once you know how to do everything I just covered, what can you make with this? What are all the applications and implications of that? So I'll cover all sorts of things you can do with those capabilities. We have a break. Then I cover networks, how to use radios and how to connect things to the internet. Then mechanisms, how to design parts of machines. Then user interfaces. Then you pull all of that together where in your labs as groups you'll make machines. Then we have a week where instead of doing one skill, we have many different options where everybody can cover different skills. a class where we go over managing invention, intellectual properties, ways to commercialize.
Wildcard week, guys, you get to build.
You develop a final project, and then finally everybody presents a final project integrating the skills. And so each week we'll have a weekly task. Like in the large format machining, the assignment is to make a big thing, make something big. And then there's a final assignment of you pulling all of this together into a final presentation. Then every other week we have a recitation, which is not graded, it's optional, it's a supplement. But they're very interesting. One will cover the platform we use for content management in the class. One will cover lots of projects over the years from the class. One is tools for use in the Fab Lab, software and management tools. One is design principles. One is lots of different machine builders showing their machines. One is programs in the Fab Lab network, things like the Fab Academy and Fab Cities. One is economy, ways to both have businesses that make money, but also to have other notions of what is an economy. One will be on all the classes in Academy, and then one will cover the sequence of the annual FabX events coming up. So the way this will work is a weekly cycle, where in the second half of each class, I'll cover a new thing, like say networking and communication. You go off and work in the lab, there'll be regional reviews, and then the first half of the class, the following week, I'll randomly pick people with a random generator, and they'll show their work, and we'll also get to know each other. We'll talk about what you're working on. And we'll do that for about an hour. And then for about a half an hour, we'll just have a global question and answer, where people can show interesting results they had, or they can ask questions or show problems they had. And so after the 1 week, after the lecture I give, you won't understand the topic. You then go off and work on it, and then we all discuss what we learned, and then you begin to understand it, but you understand it in isolation. And then the final project is finally where you bring everything together and integrate it.
Come in, guys. Let's get started. Okay, quiet down.
Okay, so that's the schedule of what we're going to do. This is a link to a thing called the Fab Charter. And there's a detailed version of this we're going to give each of you, which is the rights and responsibilities. So a lot of work goes into making it possible for you to work in the lab. And so next week I'll show you agreements for students, instructors, and labs of what the Fab Academy is committing to do, what your lab is committing to do, and what you're committing to do to make this work for everybody, how the lab can support you and how you can support the lab. And I'll talk more about those when I come to the agreements next week in the version control. Now, this week, the assignment is just to begin thinking about a final project. This is a link to a search engine. And in the search engine, let's see, it searches, no, let's see, sorry, that's, oh, sorry, this is searching in the right place. If you're interested in drones or aquaponics, it's a search engine that searches through the history of Fab Academy. And so you can use that to browse who's done what in the past. And for this week, I just want you thinking about a final project, just to start planning it. Next week, you'll build a website to track your progress. The week after that, you'll begin designing it. And so your project may change. You're not fixed to it, but the goal is just to start thinking about what your project is going to be. Okay? So that's the schedule of what we're doing. The next thing that's going to happen after some discussion is in the Fab Academy, you're not done by the calendar. You're done by progress. So you have a local evaluator, and then they're checked by global evaluators. And so in the computer-controlled machining week, the assignment is make something big, but we cover things called tooling, speeds, feeds, path planning. Those are the sort of skills. And so each unit has a set of things that get checked for the skills for that unit. And then once you have all of those done, you're done the Fab Academy. We hope everybody here will finish on the schedule. But if you don't finish on the schedule, you don't fail, you're just not done yet. And so in a little bit, we're going to have presentations from people who didn't finish in the last cycle, but they're going to be doing the final presentations in this cycle.
Is she like coming in here?
But before we get to them,
No, that's good.
I want to ask, we just covered a lot of stuff, and so are there any questions or comments from anybody in the world?
It's funny because.
So just go ahead and unmute if you want to ask a question or make a comment, and I'll do flow control if a few people talk at once.
Hello.
Yeah, go ahead.
Um,
So let me ask
You
you,
mentioned-
so Felicity, let me ask you to, sorry, each time you unmute, let me ask people to introduce themselves first, and then make a question or comment. Go ahead, Felicity.
I'm Felicity, local instructor for Fab Lab Winam, Kisumu. And right now, I
I'm
heard
sorry,
you mention something.
Sorry, Felicity, explain where Winam is. Explain where Kisumu is.
So Kisumu is in the western region of Kenya, Africa. It's a new lab that started, I think, this year. Yeah.
Good.
Pardon?
Good. No,
Yes,
go
it's
ahead.
a new lab. Yes. So because we are in Kisumu and we had, you mentioned there's someone who's in grandmother. Are they still there? Can we meet them? And also, second question about the $1,000 Fab Lab. We have a lot of people interested in starting Fab Labs, and I think it would be a very good initiative to help people start, make a lean startup for Fab Labs as they scale up. I wanted a little more information on that.
Yeah, so Jens, I mentioned, the designer who traveled the world, visited Obama's grandmother at a lab that was started by Norway's aid agency in Kisumu. I don't know if anything is left from that history. So to everybody, if you find my name, you'll find my public email address if you search. Felicity, if you send me a note, I'll introduce Jens if you don't know him already, just to check on what he was doing in Kisumu. On the $1,000 lab, so just send me a note with your question and I'll forward it on to Jens. On the $1,000 lab, we're going to have both a recitation and a few-week unit on machine building. There's a couple interesting aspects there. So one is almost every lab has some version of making a machine, but a lot of the machines aren't very good. And so one of the things happening is a really nice collaboration of machine builders around the world building a technology base to not just make a machine, but make a really good machine that performs well. And then related to that is you could make everything in the lab, but it's a lot of work and needs a lot of skills. You could mass produce it, and so that's led to some of the things spinning off from it. But one of the interesting things that's happening is creating super fab labs. So not just a regular fab lab, but regional super fab labs to make the machines for local labs. And so there's been some discussion with, in Kenya with Kamau and Gearbox, for example, about a national super lab with bigger tools to make the tools for smaller labs. And so we'll be covering a lot of that throughout the cycle. And one of my biggest goals in this class is to propagate the skills to get you all making machines. So you don't search for the $1,000 machine, but you have the ability to make the $1,000 machine. And so we'll be talking a lot about that.
Neil, I'm just going to interrupt for a second to say that I'm going to have to sign off, but I'll also add a note. If you have super labs and regular size labs and even distributed partial labs, the governance of that system needs to scale in proportion to those three layers. So again, as you build out the technology, I want to encourage everyone to also be thinking about how is this going to work in society. That's my final thought to share with you. But I wish everybody well. You're starting on a very exciting journey.
Okay, other questions or comments?
Hello.
Yep, go ahead, introduce yourself.
Yes, my name is Rodrigo Gamboa. I'm in the Fab Lab Yucatan, that is in the south of Mexico. And my question is, I see that there is like this Fab Academy, that is like, I think this specialization with the digital fabrication, with the textiles. And I'm very interested in the intersection of art, science, and technology. So my question is, there's been an attempt to formalize an academy on arts?
So, okay, interesting question. There are many suggestions for adding academic classes.
Now it is.
Another suggestion has been management, just how to run a Fab Lab. But here's the issue. For these classes to work, there has to be a body of knowledge that's empowering, that's in demand, where you can evaluate progress, and it's empowering to master the skills. And so the shading here is we work with a number of artists throughout the lab network.
I'm good today.
But I'm not sure the format would work. So there's huge demands to invest in people with the skills in transforming regional economies. And almost everybody listening today is very interested in art in some way. But I'm not sure a dedicated art class would meet the threshold of everything you need to do to be an academic class. And not only that, you need a global coordinated team to teach it, organize it, and run it. So my answer is whenever anybody says, is there a class in blank, is to challenge them to say, try to put it together. So what would the curriculum be? How would you evaluate progress? What does it enable you to do? Who's the global leadership that would curate it? Those are all the kind of challenges. By the way, your question reminds me of an important point, which is there's no global accreditation. It doesn't exist. So we made up our own credential because nobody knows how to accredit this. But what's happened is a number of traditional accreditations recognize our accreditation. So we had to invent a new way to accredit this work. And so I turn your question around to you of what would it look like to make that class? Try to design it, try to put together the team. And it's a hard threshold, but if you can pull it together, we could add a class.
That sounds great. Thank you.
Okay.
Hey, Neil, can you hear
Other
us?
questions? Yes, go ahead.
This is the Dassault Fab Lab just outside of Boston.
Hi,
Great.
Neil. My name is Jose Martinez. I have a question about your class on May 29th. Even though building the products and making them from idea to reality is what at this stage I think you do now. I agree with Joel on the how to regulate things, and your class in May 29, invention, intellectual property, income, and how to set up a legal entity, I consider that very important. But how do you manage that in a global context? Because every country has its own regulations. So I'll be interested in hearing from you about that.
Yeah, so each week what's linked is just an outline, and then there's a bunch of things that branch out from that. But in that class, I go over mechanics of types of IP, and a big part of this class is helping explain why patents are useless for most people in Fab Labs, but other ways to protect inventions. I go through a number of ways to invest in commercialization of what you're doing, a number of also partners we work with. the best way to understand, so part of the answer to your question is mechanical. Like I cover rules for intellectual property that are global versus rules that are local. But a lot of your question has to do with, again, one of the things Joel is an expert in and he studies is lateral alignment, how distributed organizations work. And so the Fab Academy is a microcosm of everything we're saying. There's no global accreditation, there's no global currency, but we created a distributed global campus linking together all of the local rules. And there's a number of examples emerging like that where you can use the Fab Lab network as a global fulfillment platform. There's a number of interesting projects for how you monetize the value provided by the network. And some of that will be in the recitation, some of that will be in the class. I can't answer all of your questions, but I can show you some interesting examples, and I can also show you the scaffolding of just the underpinning of what are the applicable rules. One point of your question also is when you're done the Fab Academy, the class isn't over; it's really beginning. Once we get through all of that, I should clarify: in one of these units, you can't become a master of any of these topics. But what's going to happen in each class is you'll learn what the topic is to know when you should care about it. You'll learn the basics of how to do a simple example, and then you'll learn about how to follow up. And so in that class, you will learn how to, the basics of what you need to file a patent and how to know when you should and shouldn't file a patent. But it takes a lifetime to become a master of patent law. And so each class is aiming at those three scales of what is it, how to do a simple example, and then how to go further.
Anything of value in life is that.
We have a question from Veritech Fab
Ask
Lab.
your parents to
Go ahead.
She's learning the craft.
From Fab Academy in Lebanon. I got two questions actually. The first one is around the final project. Does it need to be an innovative product, or can it be something already existing and we are just reproducing it? So that's first. So for example, if I'm willing to build a CNC machine, let's say, is it okay? And as for the second question, are we going to tackle the subject of mass production, like how to go from rapid prototyping and go further into how to mass produce those products? So that's it. Thank you.
So I can buy it.
To the first answer, these are the questions your project has to answer. It doesn't have to be novel. You can build on something somebody else has done. But to take your example, if you're going to make a CNC machine, there have been endless versions of do-it-yourself CNC machines. And so I do want you to know who's done what before and have a clear understanding of how what you're doing relates to what's done before. So in some sense, you should build on the past. So I don't want you to just reinvent a bad CNC. I want you to learn from existing CNCs and in some way enhance it, improve it, extend it. The standard isn't what you need for like a patent or writing a research paper. You can do something somebody's done before, but don't just copy it. In some way, improve it, enhance it, change it, extend it. Bas, do you want to add something?
Okay, here it is.
Yeah, I'm an ex-student, ex-instructor, half member from Reykjavik, Iceland. I think I would like to point out the fourth word there as well. That is masterpiece. So your final project is not necessarily, it can be a product, it can be a precursor or a prototype of a product, but I think it's better to not look at it as a product, or a prototype for a product, because your Fab Academy final project is supposed to show that you can, supposed to show off what you have learned. So it has to include some things that you would never need to do yourself in your rapid prototype. So keep that in mind for your final project, for where your final project is in your prototype.
Good. Okay. And then for your second question, there's maybe 3 parts to answering that. One is a lot of what I will be covering is what's called design for manufacturing, how to make your designs manufacturable that is relevant for any production. I will talk about partners we work with for the transition from prototyping to production, but there's an assumption to be very careful about. If you compare laser cutters to inkjet printers had a lot to do with how Hewlett-Packard survived, but they had to fight because the managers thought inkjet would be slow compared to laser printing. But inkjet printers are good if you're making a lot of different things. And so a huge number of printers, each printing a few pages, has the same capacity of a few printers printing a lot of pages. And so to go to market, to go to scale, one way is to ship it to a factory for mass production. The other extreme is have a lot of sites make it locally. And in between, there's intermediate scales. And so part of what we'll be talking about is not just the transition from one prototype to huge volume production that only makes sense if you're making the same thing over and over again, but intermediate scales of distributed medium rate production. Now I'm going to interrupt now because those were good Q&A, and that's what it will be like in the class. Watching the time, we now need to switch to the remaining presentations. So I'm going to go into prior years, 2018, final projects, and we have a few people from last year, 4 people who are going to do presentations today. So let's switch to that. So is Sarang in Kochi?
Yes.
Okay. So can you introduce yourself to everybody, Sarang?
I'm Sarang. I'm 10 years old. And I'm from Kochi. And I like to invent robots.
So Sarang was the youngest student we've ever had. So Sarang, I'm going to play your video now, and as I play your video, can you talk through it?
Okay.
Go ahead, Sarang. Tell us about your video.
So this is the design of my project.
Oh, let's see. I'm having trouble getting the network to load it. Here. I'm going to open your slide first. Let's see. The data's coming in very slowly. Here. So hopefully the video, I'm going to have the video loading in the background and load your slide. And so because of the slow connection here, go ahead and talk about the project, and then hopefully it'll catch up. So tell us about the project.
So I got the idea to make this project because in India there are a lot of poor workers who are cleaning the unused wells. So these unused wells contain poisonous gases. So the poor workers, they breathe in these gases, they don't know about these gases, and they die in that time. So I thought I can make a device for them so they can detect the poisonous gases present in the well and our unused sewage pipes and all.
Now, what is the sensor that you're using?
There are 3 sensors. One is MQ7, MQ5, and MQ135.
And what do they detect?
They detect methane, ammonia, then carbon monoxide, carbon dioxide, then, yeah.
Okay. Oh, this is good. So now you're going to use baking soda and vinegar to make CO2 and detect it?
Yes. That's the demonstration.
What's that? Yes. Just like following the puppy, man. You can't.
Okay. I keep pausing because the video is very slowly coming down to me here at the bottom tip of Chile. How much do those sensors cost?
I don't know.
Okay.
Below 200. Below 200.
Okay. That's a very important, for the part of the questions for the final project includes where did everything come from and how much does it cost? So, how much do you think your total system costs?
Oh, he's not ready.
Like 1,500. Whole system.
1,500 what? Rupees?
Rupees.
Okay. And then, as the video one of my concerns was the testing, and so it sounds like you've been able to test and show that it's working.
Yeah.
Okay.
So I'm just making the big, like the CO2, and I'll show it as a sensor, so it will detect and show poisonous gas detected.
That's great. And so, what are your next plans with that project?
I need to make it small, improve it, and make it portable, and all this big.
But so, do you plan to try to distribute it and make it accessible to workers who need this?
Yeah, like so I need to make it open source. So in the mini Fab Labs, somebody can just come to the mini Fab Lab, make this thing on a cheap price and go, or like they can sell it.
Okay, so I'm waiting. I'm watching the network slowly stream down to me here in Chile, and I want to just get up to seeing it. Okay, good. Okay, great. That looks very successful. That's a lot of progress from when I saw you last, Sarang. I'm glad to see that you finished that.
Yeah.
Okay, so thank you, Sarang, and there's an example of a project. Okay, Mary from Charlotte.
Hey, Charlotte. Oh.
Hi.
Mary.
That was kind of intimidating to follow because I'm about 5 times his age.
Okay, go ahead.
I made an environmentally responsive animal habitat. It was really sort of a proof of concept to see if I could make it for a specific type of animal that could then be changed to, any type of animal's specific needs. So what I started with for the easiest thing was like a dry desert climate reptile so that I wouldn't have to worry a lot about moisture and humidity and things like that. The reptile that this is just my daughter's bearded dragon and not the actual reptile I was thinking about. It was nocturnal, and so I had an ambient light sensor board that I designed, and when the light levels go below a certain threshold, the light comes on. It could be a heat lamp, it could be an infrared lamp or UV or something like that. And so if you had a different type of animal with different needs of humidity or temperature, things like that, you could turn on a heating pad, you could turn on, a water mister or something like that.
Good. So the one thing that's fine for scope and what you did. The one thing I'd like to see is it's not. Let's see. Let me get to the right place where you were. It's not good enough just to have a board stuck on something with some wires coming off because that'll break very quickly.
Right. I
So the one thing you.
Oh, go ahead.
Yeah, the one thing you need to do to finish this is package it. It needs to be integrated so it can keep working the day after the demonstration.
Right, I watched some of last summer's presentations and I saw that comment over and over again. The part that I was struggling with that is that the ambient light sensor is on the board And so I would have to I'd have to make some kind of clear case that the, light could get through. And so I would just have to cut some acrylic. Yeah.
Or 3D print a case with a little window.
Right.
But,
right.
Yeah, a surprising number of businesses fail because of unreliability in the field because of failures in packaging. Just the integration of the parts so it'll keep working is just the one thing you need to do.
Okay.
Okay. Other than that, it looks fine.
Okay. I was like, I have it here if you want to see it, or it looks exactly like in the video. What's up?
Sure, if you have it there.
Okay. Yeah. So can you see it right now?
Yep.
So if I put my finger over the sensor, the light comes on. And when I take it away, the one problem, there is a problem. If you are close to the threshold, it frenzies. So if you are seizure prone, don't look at this.
So the way you do that is what's called a Schmidt trigger. You have different thresholds going up and going down. And so if the signal's rising, there's one threshold to turn it on.
Mm-hmm.
And when the signal's decreasing, you have a different threshold to turn it off, and you have a band between them. And that's how you fix that problem.
Okay,
that's called a Schmidt trigger.
Anytime your hand gets a little near it, it just flickers, and it's really startling and kind of upsetting.
Yeah. So just, you put a band between them is the way to fix that. Good. Okay, thank you, Mary.
That's in the code?
Yeah, it's a simple code thing. You just have one threshold if the numbers are going up and another threshold if the numbers are going down.
Perfect. All right, thank you so much.
Okay, thank you, Mary. Franco from Pueblo.
Yes, hi Neil.
Go ahead. You have feedback. Your side.
Can you hear me, Neil?
I can hear you. Go ahead.
Okay. Okay, so for my final project, it is a digital loom. It works by controlling the headers for the design. I use electromagnets. The circuits you can see there control the electromagnets. Each string has a metal ball. So the electromagnet sticks the ball into the position where it's going to block the header. So you have to manually lower that piece, then you push all the balls to the electromagnets, and then you pull them up.
Good. And I mean, can we see it work? Can you in the video? It looks beautifully made, but can we see it actually working?
There I couldn't connect the loom, so I use neodymium magnets to virtually use the electromagnets.
Okay. So the project looks beautiful, but again, you need to document. It's not clear that it works. You need to, in your demo video, actually show the function of showing what it does.
Okay, in my page, I have a couple of videos of it working, but I thought I had to explain the mechanism in the demo video.
No, you do, that's great, but just add a little, both your demo video and slide need more information. You should show the circuits, you should show a little bit, it's working. You need a little bit more to show what it is.
Okay.
Explain, show what you did and show that it works.
Okay.
Is it useful? Do you expect to use it?
Yes, of course. I'm planning on doing a second version with less current draw. And I don't know, maybe even make a page so I can upload all the, I know, to make it accessible to schools and
okay.
I know, students.
Very good. Okay, last one, Sophie in Brighton. Brighton, are you there?
Hi, here.
Go ahead, Sophie. Yep.
Yeah, so should I talk over the video? There's audio in as well.
Yeah, talk over the
music.
video.
Okay. So basically, it was inspired by the fact that I really love to dance hip hop, and one thing that came from it was maybe to kind of make it more of an entertaining experience. And one thing that me and my instructor came up with was then to perhaps solder some LEDs onto a shirt, and then whenever I dance, with the guide strips I've got attached to my board, it changes the color. So if I have my arm up or down or whichever, the color will be different. Yeah, and then just using different kind of processing materials and methods. So, for example, my board, it came from Luis Bueno's board. It was inspired. I took his board and then made a smaller version of it. So using all the things that I would need for my particular project. And then I 3D printed a case for the board so it'd be protected inside the sleeve using PLA, and then I laser cut a battery case that I can then use to kind of protect the batteries.
So that's very successful for all the skills in Fab Academy. How well does it work for you for dancing? What's the user feedback?
It was quite well. So I don't know how well the video played on everyone's end, but if I show, well, it's kind of hard to see because the lights are on here, but you can kind of see it changing colors. And it was quite comfortable to wear, which was
have you had
quite
good reactions from other people?
Yeah, actually, a great thing is that I recently went to a job interview, and they had asked me to talk about my CV, and I put Fab Lab in there, and then they came to asking before they showed their projects whether I had anything to show, and I couldn't think of anything, so I was like, I'll show my Fab Lab site. And long story short, by the end of the day, everyone in the company had heard about my project and was raving about it, to the point where one guy had said that he knows a couple of people in a company named Telecom here that would be quite interested in a project like this. So I'm reaping the successes.
So that's great. This is a beautiful moment to stop on. So that's a great little microcosm for everybody of what can radiate from these projects. And this is a really good example of everything I'll be repeating over and over. This shows the range of skills. It's packaged. It's integrated. When it's done, there's just this beautiful thing. Your clothes is glowing, and this is everything that makes it possible. So that's a really nice one to end this introduction on.
Thank you.
Okay.
Yeah. Sorry,
well
I forgot to say my name. Sophie Carrier.
Okay. Well done.
Thank you.
Okay, and with that, we're now going to break. We take a 15-minute biology break. And so we're going to stop now. We're going to start at 1:15 for the rapid-fire introduction to meet labs around the world. And one note to the instructors, the video ports keep climbing up. We're at 1:30 now. There should only be one connection per site just to keep the capacity for the video conference. So with that completes the introduction, a 15-minute bio break, and then at 1:15 we're going to meet all the labs around the world. So I'm going to stop the recording and drop off the video, and I'll see you all in 15 minutes.
Neil, I have to sign off.
Okay, glad you could join. Bye-bye, Alan.
Yeah, talk soon. Bye-bye.
Recording has stopped.
Attention. This was a lockdown drill. And now we are all clear.
Hello, is testing audio.
Go back to regular activities. This isn't all clear. You can go back to regular activities.
Audio works fine.
Hi, testing audio.
Audio works fine.
Is everyone all right? Okay, let's talk.
Audio test.
Hey, boss.
Yeah, I can hear you. Hi, chemistry.
We were in 602, you go to the back closet. Okay? The reason we went there is that it gives us 2 doors. In
Audio
this
test.
scenario, it would be 2 doors for someone to get to us, no matter which way they can
Low,
go.
but okay.
Okay? That's straight from the bench. And I was serious in there. Papa Major Green about it. Someone comes in, we can get our hands on it. Okay? We got a decent amount of heavy stuff in there compared to some of your other classrooms. Okay? Fine job. Everyone was quiet. We sat down. We closed the blind. So there's limited light access. All right? Thank you for doing a great job with that. Also with the head count, you need to make sure. If you are ever in one of these restrooms, get done. Get back in here as quickly as possible. Understand me? If you're here in the men's room,
Hi.
get your pants up. When you need to do it, get over
Hello.
there.
Hello.
Hi. Hello.
Gentlemen,
Hear Kochi and I can Vietnam. I can hear Vietnam.
1 and 2.
Hello, this is Brahman from YouTube.
Hi, Kamakura.
Alright, with lesson 1, everyone have it? What I want you to do is just fix the document. If you have
Hey, Kamakura.
Thank you.
Nana.
Alright.
Hey, Nana.
Hi. Hi, audio test. Can you hear us?
Yeah, I can hear you.
Thanks. Alright. If you don't have the right answer, fix it. Okay, first off, we talked about our 3 movements. Control, which is controlled by what part? Ailerons. Pitch, which is controlled by your elevators in the back, and then yaw, which is controlled by your rudder. So, down below, let's look at this. If I move my cursor down, decreasing the pitch, my elevators move down. If I move my cursor up, increasing the pitch, my elevators move up. You should be fixing these as we're going. Earth. I move my cursor left or roll left, my rudder moves left, ailerons on the left wing move up and the right wing moves down, ailerons on the right wing move up and the left wing moves down.
Hello.
And I got this blown up on the
Hello.
Actually, let's do this.
No.
Okay. Next.
Hear yourself.
Potential versus kinetic energy. Energy exists in the universe in different forms. It cannot be created or destroyed. Your airplane runs on aviation fuel. This fuel has a great deal of potential energy. Once you start the plane, the engine converts that potential energy of the fuel into moving or kinetic energy. No one should be flying. Should be paused. When you recording your instruments, your airspeed when you're on the
So I have let me answer. I have
what was our altimeter at? What was our elevation? Pardon?
What value is
that?
This is Martin from
Hello.
to meet you guys.
Very good. All right. Now, when you are flying, we'll do these in gradual. Potential energy. When you were descending, what was happening to your airspeed? Is it going up or down? Up.
Oh, hello.
Attitude indicator.
Hello.
Brown or blue?
And
What was happening
we
to
see
your elevation?
ourselves.
Up or down? Now, let's look at
Self view.
when you were flying up.
Audio testing. Testing audio.
Attitude indicator, what color? And what's happening to your elevation? Up. Okay, so what does this mean? You as a pilot want to go faster. Which way do you point your nose? You are flying faster and faster. Kinetic energy going up or down? Very good. Turns of energy. Why does your plane slow down as you climb? What are you trading? Yes, you're trading kinetic energy for potential energy. You don't touch the throttle. Can you climb and fly faster? No, doing both at the same time requires more energy. Why is it dangerous to fly low and slow? Okay, you could crash. Mark.
Reminder to everyone, when you're done audio testing, remember to mute again.
Correct. If I want to gain airspeed, which way do I want to go? Down. But if I'm already low, can I gain airspeed? No.
Ivan, I can hear you adjusting your camera.
Also, if I'm already flying slow and low, and I want to pull up to build potential energy.
Your microphone is
Can you
open.
hear us?
I can hear you adjusting the microphone, the camera.
If I'm flying a second.
Yes.
No. Okay? You are in a dive going faster and faster. At some point, the airspeed will stop increasing. Why? Very good. Terminal velocity. When an object falls, drag increases. When drag force equals downward force of gravity, net forces. Eventually, yes. Okay, weight. Weight is our second force. Do not get confused by this. You may have heard adults at some point in their life try to use the word weight and mass interchangeably. That is wrong. Weight is the calculation of mass times gravity.
Hello.
Alright, and one of the focuses that we learned this semester are
Hello.
in this lesson you talked about the
Hi,
three
Vinam.
loads.
Yep, your audio is working.
Typically, what you should see here on this chart is an increase on bar chart like this. How many people got that? Okay?
Ivan, could you mute your microphone?
Anyone from Fab Academy?
You.
No? Okay, good. You did, Reese? Okay. Alright, so some people have this. Yeah, this is why, and I'll explain this. It's like almost anything that you do. The more you do it, what happens? The better you get at it. So, think about this. If you were at the 300,
Low but there.
you might have pulled up later because you're being a newbie, which is fine. 600, 900. The other thing, by the time you get to here, how many times have you done it? At least 3 here, and then 3 here. So at
Yep,
minimum,
can hear you.
just get better at taking off. You're keeping your yoke straight, you're flying down the runway, you're
Testing
realizing
audio?
when to pull up sooner, you're just becoming better at taking off.
Audio works.
So that's all right. But overall, what happens to your takeoff distance? As I increase your payload, what happens to your takeoff distance? Comes along. There's a longer takeoff distance means more or less payload. Does the airspeed go up and down?
Hello, can you hear me?
Slightly up,
Yep,
okay?
I can hear you.
The larger airplanes require
There's a bit of an echo though.
I'm going to show you an example of this. Here is Charlotte Airport, okay? And I'm going to show you on maps.
Check.
Okay? So, here's Charlotte Douglas. Is everyone see it on a satellite?
What about now?
I'm going to zoom into, this is 2000
I try audio.
on the,
That's better. No more echo.
Now I'm going to go into
Thank you.
Thank you.
Audio check from Siena, Italy. Can you hear me?
Yes, Jana, loud and clear.
Thank you.
There is a local airstrip off of Albemarle Road, 2427. Okay? Up near Mint Hill. See it right
Audio
here?
check from UAE.
Jen Howell, could you mute your microphone?
What I want to show you, here is 1,000 feet. Okay? There's 1,000 feet. What do you notice? Way bigger. Why? Why is Charlotte Douglas runways way bigger? Ryan, larger airplanes need what?
Audio check from UAE.
Because what do we know about the weight? Correct. We are completed lesson 1 and 2.
Sound check from Charlotte Latin Fab Lab.
Hello.
Loud and clear.
Remember, Friday, you need to have what done? Your essay and show your portfolio to whom? Where does the essay go? On your portfolio. Yes, right. I'll check yours out. I'll come see you.
Sound check.
I'll see you during lunch on Tuesday. That sound good? Okay. What's the other thing we're doing Friday while I check this? You're flying different aircraft. Yes. All right. Have a good one, gentlemen. We have a visor.
What time did Neil say?
What? We're on bio break right now.
Hi, sound check. Can you hear us?
Yeah. That's what it's about.
Quite low.
Reflecting back on the semester.
Okay.
Hey Tom, if I miss anything about assignments, can you write it down in here for me? So I just got we got ERB prep.
How long will that be?
Sound.
Right
I have a class 11.
Yeah, when I'm still okay.
11:05.
Okay, I'll be here 11. I'll tell my kids wait till you get back. I think all we're going to do now is introduce. Yeah, that's why I want. Now this works.
Sound.
Terrence just texted me, said he could hear me.
Sound check.
Yeah.
So if you come in here,
are you both in the same location?
it's real. It works very well. Just push the button right there. You got the mic. Your face will be more.
Duo visor ERB prep.
Checking again. Can you hear us now?
Spoke. Barely got sound.
That's interesting. From my side, it's pretty loud.
Where's pretty loud?
Fab Lab UTEC. That was the one that's pretty loud for me.
Okay, interesting. I hardly get their audio.
I wonder if Blue Jinx actually tried to balance out audio or something.
No idea, but it seems that my switching is also seems half broken. Not everybody gets switched in. They start talking.
Yeah, my broken way before it started. It doesn't even let me change layout right now.
Hi guys. Hi guys. To Fab Academy Jan from Congo.
Yep, I can hear you, Venus.
This is Cedric to Fab Academy Jan. I'm from Congo.
Yeah, I can hear you. It's with some echo, but probably due to your building, I assume.
Hi, Jason.
Hey, Rodrigo. How are you doing?
Pretty good. Just one tip to everybody who is actually coming on the stream. If you put their mouse pointer in the stream, just by pressing the space button, you will get unmute. So I think that's why people is getting unmute without them noticing.
That's true, but it's only while you keep pressing the spacebar. So as soon as you get rid of this, let go of the spacebar, it hits again.
Yeah, that's true too.
Ça a quand même les cartes électroniques réalisées au laser. Mute.
Okay, I'm back now. Is my audio and video okay?
Clear?
Yes.
Yep. Okay. So let's rejoin.
Recording has started.
Welcome back. So now for the second half, we're going to do something unusual. At the very end of the Fab Academy, we're going to go through and see each person's presentation for a final project like we just saw. In most of the weeks, we'll meet just a few people, but this time only, we're going to see everybody. So here's the list of the labs, and we're going to go one at a time, and we can do like 1 to 2 minutes a lab, so you need to all get ready in turn. And what I want you to do is unmute, be ready to unmute, and tell us in a minute or two where you are, a little bit about your lab, a little bit who's in the lab, and we'll go around the world and meet everybody. Okay? So we're off. Achim. Jan, are you there? Okay. Alto.
Hello. Hello, hello.
Yeah, go ahead.
Hello. So I'm Chris from the Alto Fab Lab. So I graduated the Fab Academy last year from Barcelona. The Alto Fab Lab is a lab in Helsinki, Finland. So it is the first lab in Finland. And I think like one reason why I'm here is also because I was studying here, so that's at the Media Lab, and that's where I got information about Fab Labs in general. We just also moved to a new location, so there are all the challenges connected to setting up the machines, and unfortunately, so there were 2 potential new students that would join the Fab Academy, but we have only 1 continuing student from last year, which is Solomon. And I'm not sure whether he's connected or not, so he's not at the lab, he's himself in Dubai right now. And if there are any questions, I could answer them now.
Is Cynthia not
That's
participating?
fine. Sorry, what's that, boss?
Oh, I was wondering if Cynthia was trying to do Fab Academy again this year.
No, Cindy, I think she's busy with some other things at the moment.
Okay, that's fine. But also, there, one of the points about Chris is there's a nice circulation of Fab Academy grads in demand to help mentor new Fab Academy sites. So you'll see a lot of global circulation. Here, I'm going to do this on the student page. So that means, thank you, Chris. AKGEC.
AKGEC? Can you hear me?
Yep. Who are you? Where are you? Tell us about yourself.
Hi, I'm Ashish Sahani from AKGEC Fab Lab. This is the Fab Lab at an engineering college, Ajay Kumar Garg Engineering College, here in the north of India, close to Delhi. And we I'm a student here. I'm a continuing student here. We have 3 instructors. We have 2 on-site, Darshan and Rahul, and then we have our board instructor Puneet, who is also joining at the moment, I think. And at the moment, for this year, we have 5 students who are in the program this year.
Okay, good. Thank you. Trying again for Achin. No. Algarve.
Sorry, this is Ahan. Can you guys hear us now?
Yes, we hear you now. Go ahead.
I'm sorry. This is Ahan. Can you guys hear us now?
Yes.
Yes. Okay. Wonderful. So this is Jan at Aachen, professor of computer science. We're at a university running the first Fab Lab in Germany since 2009. I've been a member of Fab Academy since I think 2016, and we got 3 students here this year who will be taking the class. Maybe you guys want to very briefly say who you are and what you study.
Hi, I'm Christian. I'm a master student at computer science. Yeah, I'm René. I'm a bachelor student at computer science and biology.
Hi, I'm Leon. I'm also a master student in computer science.
All right, that's us, and I think all for now. Anything else, Neil?
Yep, we'll hear more from Achin, from Jan later about design. He's a design guru. And Achin is a great example of an overlay of simultaneously being a student in the German university and being part of this global project.
Yep.
Good,
thank you.
Bahrain.
Hello, this is Fab Bahrain. I'm Dua. I'm one of the graduates from last year. We're really excited to be starting this year with 6 students. We're really excited because we actually have funding this year from a governmental entity that's funding the students to take on Fab Academy, which has been in the works for around 2.5 years now. So we're really excited to finally have this happening and coming to reality. So we've got like 5 of the students here. Maybe they can introduce themselves really quickly.
I tell you what, I'm going to interrupt. Sorry, there won't be time to meet each student in each lab. We have to do the lab-wide intros. Other than if you want to just do some highlights, but we can't do one per person. But that's 2 nice points in Bahrain. One is the spiral from starting the lab, and then each year you build this kind of capacity. And then what you described is very important in that in the Fab Academy, we expose the real cost of running it. We don't hide it. But there's a number of possible sources of funding to help cover those real running costs. And so I'm very happy to hear you were able to get government support for the participation.
Yeah, we're excited as well. Thank you.
That's great. Thank you, Bahrain. And so we don't have time to meet each person in turn, but we'll do that through the semester and then in the final projects. Right now, we just want to meet the labs. So Bangalore?
Yes, hi. Alan, this is Richard from Fab Lab Bangalore. Can you hear me?
Yes, no video, but your audio is good.
Yeah, so the video is a bit slow today. But I'm calling from Fab Lab Bangalore, and it's about 9:30 here, and we have 2 students for the course. 3 students for the course there. I'm a student of Fab Academy first year, and Workbench Projects is the name of our.
Okay, good. Thank you, Bangalore. Barcelona. There have to be people in Barcelona. We'll go on and wait to hear from Barcelona. Berytech.
Hello, this is Wael. I'm the Fab Lab manager in Berytech Fab Lab, and I was a Fab Academy student last year. Now we have 4 students this year in Beirut, and that's it.
Okay, I mean, we have to balance, so we can spend about a minute per lab. So you can say a little bit more, like, why is your lab, where is your lab?
Technically, we are currently the only Fab Lab in Lebanon. We are located on the borders of Beirut city, and our students are from random places in Lebanon. We are a tiny country.
Okay, good. Barcelona, are you there?
Yeah, can you hear me?
Neil?
Yeah, we hear you now.
Okay, perfect. Yeah. Hello, everybody. This is Santi from Fab Barcelona. We are inside IAC, Institute of Architecture, Advanced Architecture of Catalonia. This year we will be around.
Sorry, I'm going to interrupt. Sorry, Santi. Let me remind everybody, given all the languages, it's very important to speak with spaces between words. Slow down a little bit.
Okay, so we are inside IAC, Institute of Advanced Architecture of Catalonia. This year we will be around 10 students, plus another 20 more or less inside the new master that we launched this year. This is why we incorporate very nice people, as you can see here, Eduardo Chamorro as a new instructor. I think it's going to be a great year for us.
So some notes. Let's see. Is Luciana available?
Yeah.
Hi, can you see me?
Yeah. So Luciana from Barcelona does the central coordination. Can you introduce yourself?
I am Luciana. I am here at Fab Barcelona. I globally coordinate the program, so I have already been in contact with most of you. So I'm here if you need anything, and I welcome you to the program. I see some laughter there. It's good to put a face to everyone, and I see you around.
Okay, thanks, Luciana. And then a note about Barcelona. The content in Fab Academy is freely available. The videos we post, people can look over your shoulder. The charge in the Fab Academy locally is for the cost of running your lab and supporting you in the lab, and globally for the cost of participating and evaluating and documenting and supporting. And so the content you should feel free to share with anybody, and then the cost of the Fab Academy is the actual cost of participation to run it. And so Barcelona started from a little lab to a bigger lab to a bigger lab, and in some ways to the anchoring the whole city, and has a central role in coordinating Fab Academy. Okay, Batrap.
Hello, Neil. Can you hear me?
Hi. Yep.
Yes. Yeah, I'm Marcel. I'm the instructor from Bottrop, together with Tobias and Florian. I have two students this year. One is Tin from Croatia, from Zagreb, and the other one is Patrick from Fab Lab Dortmund. The thing with Tin is he is from the Volca project. That's the Europe Mobility Maker Mobility project, and that's our first Volca experience. That he is here and do the Fab Academy in Bottrop. And in 2 weeks I will start working in Camp Lindford as instructor because Daniele go to Dubai.
So I'm very happy to hear about your EU example, in that there's a lot of support for people to do this kind of thing, and so I'm happy to see them making it to Fab Academy. Tell us about Bottrop as a site.
Bottrop, so we do Fab Academy the fourth years this year, and that is my second year as instructor. Together with Aachen and Camp Lindford and Munich, we were the first Fab Labs in Germany who offer the program. And we are very happy that we can catch on and have an international class this year. So far so good.
Good. Okay. Thank you, Bottrop. Brighton.
Hi there, my name is Derek. I'm here with our 3 students for this year. We've got Michael and Kyle and Alex, who are students here at the university, students and staff as well, studying an MSc or in product design. This is our second year of running a Fab Lab in the UK. I think we're the only Fab Lab in the UK at the moment.
Doing Fab Academy.
Doing Fab Academy, that is, yes.
And then again, for each site, tell us about your site. Is it a university? Is it a community center? Describe just a little bit about the content.
We're based in the University of Brighton, and we kind of sit in between 2 or 3 schools, the School of Computing, Engineering and Maths, and the School of Architecture and Design, and the School of Media as well. We kind of work with academics and technicians in all of those three schools, and with students as well in all of those three schools. And we're kind of physically located right near the workshops where the product design and engineering workshops are, with traditional machine shops.
Great. Okay, thank you, Bryson. Sept.
Hello?
Hi, Neil. Am I audible?
Yeah. Go ahead, Sept.
Yeah,
Hello.
hi, I'm Tanvir, Fab Lab SEP, and yeah, we are part of.
Sorry, wait. CIT, it's not your turn yet. We're doing Sept first. Go ahead, Sept.
Hi, okay, so I'm Tanvir again. I am a local instructor for the Fab Lab SEP. We are located at Ahmedabad, which is a western part of India, and we are in a campus of SEPT University, which is a design and architecture school. And this is the sixth cycle of the Fab Academy. So far, we have a 26 Fab Academy graduate. This time, we have 5 students here. Samuel and Maharshi here are from the electronics background. And we have a Dhruv and Karan are from the design background, and one Dhruv again from the mechanical background.
Okay, good. Thank you, Sept. CIT.
Hello, Neil.
Yep.
Yes, I am Alejandro Tasu. I'm the instructor Fab Academy this year. We're currently 3 instructors. Fabricia Paredes, who enrolled last year, and this is our first year enrolled with the Fab Academy program here.
Take your time, get out the
We have
and start
4
doing
students right now.
your heart rates, okay?
Okay, my name is Edwin Alvarez. I am.
Again, sorry, let me interrupt. We don't have time to meet everybody in every lab. You can briefly mention their names, but we can't go through each person and stay on schedule.
So we have Edwin, who is an electrical engineer. Italo, who was an ex-student of our university, and he is an industrial engineer. Also Francisco, an industrial engineer, and Danny, who is an architect.
And then what kind of site is it? Again, for each site, are you a university, a community center? What kind of location are you?
We're a university center located in Lima for the University of Lima. We work with either academics and technicians for the industrial engineer career.
Okay,
mostly.
Good. Thank you, Lima. Chandigarh.
Hello, can you hear us? We are Fab Lab Chandigarh, City Design by Corbusier, and we are a private Fab Lab and the only architectural-based Fab Lab in the private side for India, and the second one after SEPT for India in the architectural side. And we run a first course in Fab Academy this year, and this will be our first course in Fab Academy this year. So 2019 was a good year for us, where we'll be offering Fab Academy second year 2019, and then Fab Academy second year 2019. 20.
That's great. Good. Welcome. Nice. Charlotte Latin.
Hello, everyone. This is Fab Lab Charlotte Latin. We're out of Charlotte, North Carolina.
Sorry, your level's very low. I don't know if you can come closer or raise your level.
That would be better. This is Charlotte Latin. This is better now. All right, we're in Charlotte, North Carolina. We're at K through 12 high school. Mary Fabian just presented a few minutes ago, and she's part of our Fab Lab. So we've had 6 graduates in the past 3 years, primarily teachers in the art department as well as sciences and engineering. And we now have a student last year graduated, and this year we have 4 students taking the program. And the final thing I'd like to say, Neil, is this has impacted the way we're teaching our regular engineering students. So our kids take math and traditional math and science, but they all do an engineering program. And we've learned a lot from the Fab Academy and how to teach it.
That's interesting. Say a word or two more about that.
So we graduated in 2016. Myself, the head of the art department, part of the science department, and some science teachers. I started teaching STEM, what they call engineering, back in 1989 at this K-12 school. We now, in our high school engineering program, model parts of the Fab Academy with our kids. So it's not as intense and it's not as in-depth, but we go through the whole year of it in our introductory courses, and we keep having the kids use digital equipment, digital design, and making personal projects.
That's great. I'm delighted to hear that. Yeah, and again, everybody should feel free to reuse the content. The goal is to share what's freely available to share. Good. Thank you, Charlotte.
Thank you.
Sorry. Okay.
Hello, everyone. Hello, everyone. Could you hear me? Hi.
Yes.
I'm Chen Hao from Fab Lab Chengdu. I'm the only one student here. There will be 3 instructors to help me. I retired from Air Force a few years ago and started an ecological farm and a homestay at the countryside of Chengdu. This year, I will start a children's discovery museum. So I want to build a Fab Lab in the museum. So that's why I'm here to join the team.
Great, that's great background, great goals, and we appreciate in China you have to stay up late for the class, so we're happy to have you staying up late to join us. Okay, Crunch Lab. Dassault.
Hi, Neil.
Nope.
Yeah.
This is Luciano at the Dassault Lab this year. I have Greg, who was a student last year, being the co-instructor.
Luciana, first introduce yourself. How many Fab Labs have you set up around the world?
You always ask me. I always give a different number, so I don't know. I think it's close. It's getting close to 100. Going for the triple digits.
Luciano started in Fab Labs and Fab Academy, now Fab Foundation, and he's a guru who helps support around the world. So now go ahead.
So yeah, this year again, we're here at Dassault, and we have a big group this year. Really excited to get going and happy to have Greg helping me out.
Okay. And they're at the campus of SolidWorks, which is one of the leading engineering design softwares we'll cover, and they're great partners of the Fab Lab network. And so it's exciting to have Fab Lab right on their campus and host this. Good.
Thank you.
Okay, I saw Jean-Luc there also. Can you introduce yourself?
Hi, I'm Jean-Luc Curit. I work for the Fab Foundation, employee number 2, managing the global supply chain, deploying Fab Lab inventory to about 5% of the labs within the network. That was like my folio, so yeah.
Okay.
That's me.
Good. Dilly Jan. Isan.
Hello, Neil. How are you? Do you hear me?
Yeah, I'm scared by what's across the table from you.
Hello, we are Fab Lab San at University of San. We are located in a business school, and also we are the first Fab Lab authorized by the Peruvian government as an innovation center. We have here 2 new students who are going to participate in this year. Well, thank you for being here.
Okay, thank you, Isan. FCT.
Hey, Neil.
Hi.
Hey. Hi. I'm Philippe. I'm the instructor from FCT Fab Lab. We're a Fab Lab at the university here in Lisbon, Portugal. We're a Fab Lab actually from a library here at the university, although we are not in a library due to the noise level. This year we have 2 students, Monica, which is continuing, and Antonio, and hopefully they'll give out great projects. Oh, also Andre is a continuing student as well, but he's not here today. Yeah, that's it.
Okay, thank you, FCT.
Yeah.
I saw Dilly John joined. Are you there, Dilly John? Yep.
Yeah. Hello. Can you hear us?
Yes.
Yeah, so we are the first tourist Fab Academy. We have two Fab Labs in Armenia, one at Dilijan and one in capital city of Yerevan. We are currently, we will work at Fab Lab Dilijan, which is part of Dilijan Training and Research Center of the Central Bank of Armenia. So we're very excited to see you all and join.
Okay, good. Well, okay, thank you. Egypt?
Yeah, hi. This is Haggag from Fab Lab Egypt. I'm the instructor here. Fab Lab Egypt has been an independent Fab Lab since 2012, and we're providing Fab Academy since 2014 now. This year we have 4 students, 3 new and 1 continuing, but today we had a very terrible sandstorm, so 2 couldn't come. So we have Nada here and Lamia. Nada is an architect. Lamia is a STEM school teacher. And we have also Rania, she's a CAD designer, but she couldn't come today. And for everyone, this year we are hosting the Fab conference in Egypt, so I will be waiting for you all here.
Nice, thank you. IED.
Can you hear me?
Hi, Ned.
Yep.
You want
so
to talk?
Right
okay.
now we're on IED. Crunch Lab will come back to you next. IED, go ahead.
Okay. Okay.
It's your time. Okay, Ned. I'm Marta. I will be the instructor here in Fab Lab here at Madrid. We are located in a design school. The school also has schools in Barcelona, in Italy and Brazil. And it's our first year. We have 6 students. And we are related with Nuria and Fab Leon, is our super node. That's it.
Great. Just say a little bit more about the school you're in.
What?
Say a little
it's a
more
design
about
school. Yeah, the school, it's a design school. They have like a product design, interior design, graphic design, fashion design, a lot of kind of design ambience and areas.
Okay, good. Thank you, Madrid. So now we can go back to Crunch Lab.
Hello, Neil, and everybody from Crunch Lab, Venice, Italy. We are here at our second year as a Fab Academy node, and we are one of the 3 Italian nodes, actually. We are a small independent Fab Lab in Venice metropolitan area. And this year I have a continuing student and a new student. So we are pretty okay.
Good, welcome. For the future test, there's a lot of distortion in your audio. So before the next class, just test the video conference with somebody else. Okay?
All right, thank you.
But we can hear that fine. Okay, thank you. Insight Focus.
Hi, Blair Evans from Community-Based Fab Lab in Detroit, Michigan. We just moved to a new location. We're just kind of settling in, so it's an interesting start to the Fab Academy at the same time. Primarily anchored here by Jonathan Ward and myself. We're supporting 4 remote Fab Labs this year, so I guess I should convey a hello from Haystack, SOCOM, Jackson, Mississippi, and Milken School in Los Angeles. We primarily focus here. Oh. Yeah, we need some more capacity for Fab Academies in the United States, so we're trying to nurture that.
Great.
We primarily
talk a little bit about what Insight Focus programs.
Yeah. So, I mean, at our core, we're focused on, community development activity by community residents, focusing on enhancing quality of life while staying within resource constraints. And so, that's a multifaceted kind of component, but we're working on the social and economic models to go along with the capabilities of the Fab Academy. We primarily are really trying to dive down and really implement kind of on the ground a good working model of that in one neighborhood in an urban area in Detroit and in a rural community in Michigan. And we have a registered apprenticeship program to complement the Fab Academy to help people build the capacity to get engaged in those projects. And so people are focusing on, building housing, harvesting energy, growing food, and actually contributing their work as a part of directly providing for their needs, and really kind of rediscovering that quality of life comes from experiences and activity and community more than stuff. So we're trying to help people have an opportunity to pivot back to a more rational way of going about life.
That's great. I volunteered you for the economy recitation to unpack all of that.
Okay, good to know. Thank you.
Okay, thank you, Blair. Inspur. Urbid.
Hello.
Yep.
This is Nadine from Fab Lab Irbid, Jordan. We're the first Fab Lab in Jordan. I'm the instructor this year along with my colleague Qusay. We're actually accompanied by previous Fab Lab graduates, Fab Academy graduates. And this year we have 3 awesome students, Tariq, Ahmed, and Hadir.
Great. And what kind of location are you?
So we're actually based in the north of Jordan, and we're part of a hardware incubator. In the past 2 years, we have incubated almost 100 startups. Most of our startups are based in the Fab Lab and prototyped in the Fab Lab.
That's great. Okay, thank you. Kamakura.
My name is Yuka. Hello.
Good. Go ahead.
Okay. And I'm a director of the Fab Lab Kamakura, and we have 4 students in this year. And we have 3 instructors, and 8 students graduated from Fab Lab Kamakura so far. And Asako is holding the Kamakura. Can you see our lab? It's a little like a building.
Yeah, so can you describe the building?
Yeah, sure. We have our building is almost 130 years old and used to be a sake warehouse. And this building is moved from Akita Prefecture. It's northern part of Japan. And we set up the Fab Lab in this building. And this building has tons of traditional technique. So we do care about the traditional technique and also the technology, and we can see try to find a new world in Japan. Thank you.
Yes, so this lab specializes in using traditional Japanese crafted materials with modern digital fabrication in beautiful ways to blend them.
Thank you.
Good. Comp Linford?
Yeah, hi. This is William McGill. I'm the only student at the moment. I started last year, and I'm back at it again this year to finish it off. There'll be 4 more students a little later on. We're a small university setup. This is actually a really big Fab Lab. Has been around for a while, and along with Afen and a few others, we're part of a local network here.
Good. And Adriana is here with me and Perda Williams from Comp Linford.
Excellent. That explains why she's not here.
Yeah, she's here with me. Thank you. Can I?
Hi, can you hear me?
Yep.
Yep. This is Yuichi. I graduated 2 years ago in Chile. This is my second year's instructor of Academy. And Fab Lab Kanna is opened 2030 during Fab 9 conference in Yokohama. Okay, Yokohama is just 30 minutes from Tokyo. Thank you.
Good. And what kind of location are you? Again, same question for everybody. Are you a university, a community group? What kind of location are you?
It's actually in NPO.
Okay. And same comment before for Kamakura and Kanai, that we picked the same time globally, but it means the west coast of the U.S. gets up very early, and in Japan you have to stay up very late, so we appreciate you staying up for the class.
Thank you.
Carport.
Hello. Hello, Neil.
Go ahead.
Okay, thank you. I'm Suhail from Fab Lab Khairpur. We are the part of Sakhar IBA University and the Computer Science Department. We are in the south of Pakistan. This is our second year of Fab Academy. And this year we have two supporting instructors who graduated last year from Fab Lab Khairpur. And this time we have 6 students from different backgrounds. Tariq, he's mechanical engineer, and Zishan, electronic engineer, and Ali, he is computer sciences, and Ali Raza as well, he is also from mechatronics background, and Azmat, he is also electronic engineer. So,
great.
That's it.
And it's great to see you back again with the spiral that every year you build capacity from the first year.
Yeah, this last year we have 4 students, and this time we have 6 students. That's how we are going next.
Thank you.
Thank you.
Kochi.
Hi Neil, this is Fab Lab Kochi, and myself Jojin, and this is Salman. We both are the instructors for this year. We have almost 9 students for this year. We are actually situated in southern part of India in Cochin. We are part of the Kerala Startup Mission, which is a government organization, and we are funded by the government of Kerala.
Good. Looks like a good group. Okay. Lorraine County.
Hello, this is Scott Dechek from Lorraine County Community College. We're a 2-year college in Ohio near the Great Lakes. And we currently have 5 students that are remote, some from Texas, Missouri, as well as Ohio.
Talk about the evolution of your lab over the years.
We're currently in our 3rd lab. We started out in a little tiny closet, quadrupled the size of that, and then ended up putting an addition on the college for the lab that you see behind me now. So it keeps growing, and then we've been doing more outreach. We now have a mobile lab that we can take to basically any of the businesses and centers around the area.
So again, for everybody else's inspiration, they started as a closet, turned into a building and a truck. Okay, thanks, Scott. La Caz Lab. La Machinery.
Yes, hello. This is Machinery. Yes. So we are a Fab Lab located in the north of France. We started in 2014, and we were there at Fab 10. And we went from 20 square meter Fab Lab to 200 square meter Fab Labs today. And this is our first participation to the Fab Academy with 3 students, and we are very happy to be there after some time.
I like your lab name.
Thank you very much.
Leon. Daria. Napoli.
We all do it, everybody. Try doing it. Do an experiment between the.
Can you hear me?
Yes, go ahead.
Neil?
Yeah, Napoli, go ahead.
Oh, okay. I'm Antonio Grillo. I'm a product designer, and I am lab manager since 2012 in a Fab Lab Napoli. This is our second year for the Fab Academy program. And this year we have 2 students, me and Michele. I'm a product designer with a maker soul. And usually I intertwine code and digital fabrication to giving form-finding project to computational design. Michele have a background, but I can present it.
Hey, buddy.
Okay.
I'm designer too.
Where's the bucket of sand?
Okay, good. Thank you. Yeah. No, that's good. That's plenty just to meet the lab. We'll do slower intros as we go along, but that's a nice description of the spirit of what design across all the levels is about. Your introduction is there's different types of designers, but this is sort of a new literacy of just design across levels of description that we're trying to teach. Great, thank you, Napoli. Leon?
Yeah. Hello, Neil. Hello, all. I'm Nuria from Fab Lab Leon. We are located in the northwest of Spain. We are part of a non-profit foundation in a small company, a small local company. And we have been open for 8 years, almost. And we have grown also from 100 square meters to 600 square meters is like our space now. This year we are contributing to make the Fab Academy networking role, and we will supervise 4 remote Fab Labs with Fab Lab managers students, like they are from different universities here in Spain that are very far away from our space. Okay, in our Fab Lab, we are open to the community. We are specialized in making courses for kids and making some creative courses and so on. We are handling also regional reviews for knowing all the students in all the networks. So you are all welcome to our regional review, but they are specialized in Spanish, but you are all welcome. Thank you.
Yeah, and so to note that the regional reviews are optional, not required, but encouraged, and they're done in local languages and local time zones to spend more time locally before the giant global meeting. Okay, thank you, Leon. Shanghai.
Hello, Neil. This is Saverio. I'm the local instructor here in Shanghai. We are inside Tongji University's College of Design and Innovation. We are...
Let me ask, Saverio doesn't sound like a Chinese name. Can you explain your background?
So I am from Italy. I did the Fab Academy in Open Dot in Milan. Then I became an instructor in Paris, and now I am an instructor here in Shanghai. Actually, this year we have a very nice melting pot of nationalities. Our students are from China, Mexico, Russia. The instructor is Italian. Right now, out of 6 people in this room, there are 5 different nationalities. Our Fab Lab, the name is Fab-O. We are known as Fab-O. We are also created a network of other Fab Labs around the region here in China. We have a biolab, and our latest addition is a shipping container, transformable shipping container that is a mobile lab that right now is in Shenzhen, and we are probably moving to Hangzhou to the Alibaba campus. That's it.
That's a lot of it. That's great. Ulu.
Hello, everyone. Just to answer to Salverio, so we have 8 nationalities with me here. So I'm Jani from Fab Lab Oulu. I'm a founder of this Fab Lab and a chairman of Nordic Fab Labs Network Association. And this Fab Lab is part of the multidisciplinary University of Oulu. And it's located only 200 kilometers from the Arctic Circle. It's totally dark here, day and night almost. And so being just 200 kilometers from Santa Claus's workshop, it's a little bit cold place. I have a very exciting group of students with me here. They all can walk on water.
Good. And Do you want to say anything about the incubator?
Thank you. Yes. So we are running a Grow with Fab program. It's incubator for instance, anything you come up with your final projects or company ideas or anything. We try to do in 9 months everything that a startup company does in 2-3 years as in incubation, while it's also a hardware acceleration. So we are doing it together in collaboration with Fab Foundation and big companies. That we are actually connected mostly through Fab Foundation. The chairs are in Barcelona, Thomas and Ohad in Israel, and myself at the moment. And it's part
this
of the
is an
academy.
emerging project. Yeah. But the idea is rather than you going from here into an incubator, we bring the incubator to you to incubate across the network. And you'll hear more about that later in the cycle. Okay, thank you, Yanni. Polytech.
Hello, everyone.
Yes, we are here. We are here actually.
Yeah.
Can you hear me?
Yes, I hear you. Yes.
We hear both of you. Go ahead.
So my name is Pavel Bilenko. I'm a founder of Fabinka, which is a Fab Lab in Kaluga. Kaluga is a city in 170 kilometers from Moscow. And we started in 2014. Since that, we organized approximately 30 workshops and activities around 3D printing, and we have done it in the city center. Kaluga is known as a motherland of Russian cosmonautics because some of the major scientists were born here in Kaluga. So we are going to develop a Fab Lab and the community around Fab Lab. Thanks to include us in the Fab Academy program.
Great, and it looks like you're on a train.
I'm now doing the way from Moscow to Kaluga, so Ivan maybe he can say something else. He now in Kaluga, he's working in the area of the Fab Lab. Yeah, Ivan.
Okay. Well, and then who else was answering from Polytech a minute ago?
Paulina is here as well.
Paulina?
Yes, I'm here.
Just to introduce yourself.
Yes, I was the student of Fab Academy in 2015, and our laboratory is in Polytechnic University. And yes, this year I have 2 students, and they are from Kaluga, and they already have their own Fab Lab there. And I hope that share this program, we can improve Russian society in this maker's way.
That's great. Okay. Thank you. We're going to keep going for time. Puebla.
Hello, everyone. This is Luis Camacho from Fab of Puebla. We are located 2 hours away from Mexico City. This is the 4th year we have Fab Academy here. This year we have Rafa, Leti, and Carlos. Rafa and Leti are, their background is computer science, and Carlos is business engineer. So we will have a very interesting year in Fab Lab Puebla.
Great. QBIC. Rwanda.
Hi, can you hear me?
Yep.
Hello. Hi. Can you hear me?
Yes, go ahead.
This is Tasneem from Cubic Fab Lab. I am a Fab Lab instructor for Fab Academy, and we are based in Qatar under Qatar Business Incubation Center. Actually, we are very excited because it's for the first time in Qatar to have Fab Academy and to host it. And we have around 8 students from different, very nice group from different backgrounds, different disciplines, and we are super, super excited for it. And actually, what we're doing here for Cubic is that we're helping incubatees and startups to prototype their ideas. And yeah, so this is what we're mainly doing here.
Good to meet. Welcome. Rwanda.
Hello, Neil. So this is Fab Rwanda. Hi. So we are located in Rwanda, in Kigali, mostly. So we are currently one Fab Lab in Rwanda. This is our third year doing the Fab Academy. So for this year we have 5 students. And now we are set up the other Fab Labs. Currently in Kigali we have another makerspace. We are helping just to set up. So we hope you're going to enjoy this class.
Good to see you all. Shenzhen Open Innovation Lab.
Hi.
Shenzhen, you have bad feedback. I'm going to go on. See if you can get headset or fix your feedback, and then we'll come back to you.
Hello.
Open Innovation Lab.
Sorry.
Business trip
Wait.
in right now. So we are with and a community manager from this studio and Child X Factory, which is also a Fab
Lab. Just sorry, can you repeat that? There was some interference. So Winam, hold on. Shenzhen, just recap again your description, please.
Okay. Hi, we are from Shenzhen, and our instructor is on a trip now.
Okay.
And then we are here. We are the students for this year, and my name is Violet, also known as Haiyan, which is my Chinese name. And I'm a community manager at Child X Factory, which is a Fab Lab, and also a community manager at C Studio.
Hi, I'm Yu. I'm a continuing student.
So this, for everybody else, this is a very important lab because the Shenzhen lab is closely tied in to the Shenzhen manufacturing ecosystem. And so these are great partners for the transition from prototyping into production through Shenzhen. And they're close to one of my favorite places on earth, which is Watong Bay, which is very real. Okay. Now, we're not up to you yet. We'll come to you. Thank you, Shenzhen. Santa Chiara
is made in this area of China.
Hello, greetings from Siena, Italy. We are Santa Chiara Lab. We are hosted by the local university, and this will be our 4th cycle of Fab Academy. I graduated in 2017, and I've been working with this lab ever since. And this will be my first year as an instructor, and we hope we'll have a wonderful experience this year too.
Great. Thank you. Seoul.
Hello, 안녕하세요. This is Rodrigo from Seoul. I'm here with my student. I have 2 students this year. We are in the middle of the city, actually called the Maker City. It's not like Wachambe, but actually you can actually go and buy sensors, Arduinos, acrylics, the wood, everything related to the Fab Academy, and all the inventory actually at like 5 minutes walk. So actually we are in a very privileged space. Yes.
Yeah, Rodrigo doesn't sound like a Korean name. Talk about your history.
Okay, I'm from Chile, by the way. I should be with you. I really want to go there. And I've been here for kind of like 12 years now. And actually, Eduardo Chamorro, Barcelona, who is doing the instructor, he started the Fab Academy about 5 years ago. He did the 3 first academy, where I took the class in 2017. And I did a lightsaber that is really nice. And actually, and after that, Eduardo back to Barcelona, and I had to take the Fab Academy as an instructor. So this year is my 2nd year, And then I don't know. It's like, yes, I'm having a lot of fun, and you know.
That's great.
By the
okay.
way,
thank you.
We are an NGO. We're an NGO. We're open to the public, so anyone can access the lab. Very open, and also it's very safe. Yeah, that's it.
We need to keep up our speed. Singapore.
Hi, my name is Stephen. We have two instructors here, myself and Rodney, who graduated Fab Academy in 2015. We are part of the Singapore Polytechnic Tech Center here. SB offers diploma level courses in various areas of business, media, design, engineering. We have 15,000 full-time students. And this is our 5th year offering the Fab Academy Diploma Program. We have 2 students this year, Lucas from Singapore, as well as Fitsum from Ethiopia. Fitsum is actually still in Ethiopia at the moment. He's making arrangements to travel here to Singapore for the Fab Academy Diploma.
Okay. Thank you, Stephen.
Thank you, Stephen. Surban.
Hi, Adele here from the Fab Lab Sorbonne. I'm the head manager, and we have 5 spaces here, a biology one, geology one, a creativity one. So the Fab Lab here is like spread everywhere in the university. And we have 5 students, so you will meet them after.
Good. And again, this is a nice example of an overlay of a Fab Lab overlaid with a traditional institution, which I like very much. Okay, thank you, Serban. Texas.
Yes, this is Fab Lab Texas. Texas is in Peru, in Lima. This year, the Fab Labs are open in 2014, and there are 5 years. And now, this is my case. I am instructor for 4 years. This year is a challenge from Texas because there are 9 students, a lot of, but it's a big challenge to make okay all. Texas is an institute, technological institute. Technological institute.
Okay, thank you.
Thank you.
Taipei.
Hello, this is Ted from Taipei, and I'm here with 2 students, Qingxuan and Wei Song. We have 4 students this year, 2 in Taipei and 2 in Macau. This is our 6th year to doing Fab Academy, and we have 10 graduates already. And this is a community lab, and everybody can come. And that's it.
And then, Ted, talk about organizing FAN.
This year, the FAN event gonna be in Seoul.
No, but sorry, step back. What is FAN? How did it come about?
FAN is stands for Fab Lab Asia Network. So it's a regional conference, similar as a Fab conference, but just in a smaller scale. And this year is gonna take place in May in Seoul, Korea. So right now, Haebin from Seoul Innovation Lab gonna organize an event. So it's actually open to everyone. So if you have time in May, please join us.
Yeah, so it's a good example of organizing a regional event that's been very popular. Okay, thank you, Ted. Tech works.
So create a ped tab. Don't worry. On a tab, this should be
Trivandrum.
engineering. Let's get it on here, guys. We only got about...
Hi Neil, it's from Trivandrum in Kerala, southmost state in India. So we have 2 nodes. One is course they have already introduced, and we have 2 labs and 20 mini labs in various universities. So we are owned by a government organization. Kerala Startup Mission is an incubator basically, which supports and builds the startup ecosystem in the state. So we have been conducting. This is our 4th cycle of Fab Academy. We have been since 2016, and in 2016 we didn't have any local instructor. So we had a pre-academy training, some one-month training with the help of Fab Foundation. It made the students capable of running Fab Academy without local support. Yeah.
And yeah, these ones in Kerala are a good example of a state investing in a network, part of the infrastructure for the state. It's thoughtful government leadership making it possible.
Yes.
Good. Thank you, Trivandrum. UAE.
Hi Neil, this is Hashim from Fab Lab UAE, and I am Fab Academy instructor with famous Daniele Ingracia. And we are part of Hamdan Foundation, which is a governmental organization, actually non-profit, and it is actually a super fab lab that is open to public. And we aim to empower the UAE economy with digital fabrication by giving scholarships, actually full scholarships to UAE nationals, as well as conducting workshops, maker fairs, and camps as well. And we are trying to get this diploma accredited here in UAE. So Daniel, you can continue.
Great. Now, Danielle, it doesn't sound like you're from UAE. Talk about your history.
Yeah, sure. So 3 years ago, I used to be a computer scientist when I took Fab Academy. And after that, I decided to spend, I think, all the rest of my life in Fab Labs, like night and days, and developing a lot of projects. And yes, I'm here to push as much as I can the Arabic networks of Fab Labs to make. And yes, while I'm here, I count also to push forward to develop other projects. And yeah, that's it.
So Danielle, can you just give a table of contents of projects you're working on?
Yeah, so sure. I love to make fabric boards, so I did a lot of electronics for almost anything, like stepper drivers, microcontroller boards, small, big, with a lot of different functionalities. I did a lot of drones myself since the final project. My drone was able to avoid obstacles, for instance. And then I also used this drone to make workshops worldwide in China, Italy, and so on. And then I also did a special drone with Neomena from Barcelona to 3D scan clay printed structures. Then I'm also making machines, so I built a huge laser cutter, which I brought to France, I hope that you remember, and which is still undergoing development. And yeah, I also did a very small project, like open source oscilloscope, that I used to teach kids electronics. And yeah, there will be many more. I hope.
So Danielle will be doing a recitation to talk about many of these kinds of projects. Okay, thank you, UAE. ULB.
Neil, hi all. So last year we had a utopian plan, and it worked. So we are a Fab Lab that's we are in a university. And we are a Fab Lab that comes from the Faculty of Architecture, and we wanted to open it to different faculties, and so we did it. So we have engineers, science, law, architecture, of course, and we've got many more that will come. We have moved to a new campus, so now we have 1,000 meters square. We are close to our friends from the Flemish University, that have got also a Fab Lab just below us. So it's like a new campus that's growing. And we have like half will be research and half will be about the Fab Lab, Fab Academy. For the research, we got science, but we got also law. We got lawyers coming close to here for PI. So it's very exciting. And for the Fab Academy, where we just have 2 data points, we are tripling every year. Because today we'll have 6 students and 4 instructors. So if it's keeping up like this, that's a lot. And they are from everywhere. So we got outside students, but also technicians, graduate students, and professors that are from outside also. So that's it. So
and UOB has done interesting stuff on algorithms and materials for fabrication that we'll probably hear about as we go.
Cool. Yeah.
For the future, just your audio level is a little bit too loud, a little bit too hot. Just check your level for the next time.
Yeah, but you will change because we have to set up the lab here, which is, it will change.
Okay, good. Okay, welcome ULB. Utek.
Hi Neil, can you hear me?
Yes.
Okay. Isaac Robles, I'm a manager of Fab Lab Utek. This lab is established in engineering college in Lima Group in the district of Barranco. We have 3 years, and actually the lab has gone through a series of interesting transformations. One of the main project lines we have here is actually making our own machines. There are, I think, a few on frame. And here's Jonathan, who is actually our current student for the cycle.
Okay. Good. Welcome, Utek. Vancouver.
Thank you.
Hi, this is Jason, an instructor in Vancouver.
Peter is actually a remote student for me. He's the first student from Seattle area. So I'll let him introduce himself.
Yeah, so really briefly, I'm just a retired IBM and Boeing engineer.
Okay. Good. What kind of engineering?
Well, my undergrad is in mechanical, but most of the stuff that I've done is computer science type stuff. The fun fact is my makerspace is right across the street from where they make the 787.
Oh, nice. Okay, good. Glad to have you joining. Vigyan Ashram.
Yes, Namaste Neil. This is Supriya from Vigyan Ashram. And this year we have 7 students from 5 different states of India. And we have 5 instructors. And Vigyan Ashram is a lab which works on rural technology development and appropriate technology development. It is 70 kilometers from the city. Now we all have stayed in Pawel and connected from Pawel.
Okay, just a moment. Utek and Tasneem, you need to mute. Okay, so Vigyan Ashram, I'm just zooming. This is one of the most remote Fab Labs. So I'll go to satellite. In this, let's see, here's the Vigyan Ashram Fab Lab, and then it's outside Pabal, which is this little town in a remote part of Western India outside Pune, which is then outside Mumbai, but it's a fully functional, globally connected Fab Lab in this remote part of India. So it's one of the most remote but lively Fab Labs in the network. So who's with you there?
Thank you, Neil. Yes, so we have 7 students, and this year we have 5 instructors.
Great. Okay, good to have you joining. And in fact, the inspiration for all Fab Labs really came from Kalbag, the founder of Vigyan Ashram, who was one of my dear mentors. Thank you. Vaag, Amsterdam.
Hi, Neil. So this is...
Hello.
Can you hear us? Okay. This is Henk from... I'm new student. So I was student last year, a new instructor. We have 5 students, 1 continuing student. We are located inside probably the most beautiful building of the city, at least so the oldest building in the city. We are accompanied by 2 people from Fab Lab Suriname, Lakaslav and Theo. Can you introduce?
Yeah. Okay, maybe I can grab the opportunity because I saw that Kaslov missed their introduction. We got a unique opportunity from the government of Suriname to set up not only a Fab Lab, but a network of Fab Labs. So we got we're head on the way to establish at least 3-4 Fab Labs in the coming 2 years in Suriname. And with Kaslov and friends Academy for 2019. So thank you for that.
Great. Okay. Glad to hear that. And yet the Vaag is in the old customs house that was like the most beautiful building in Amsterdam, but neglected for many years, and they've turned it into this great facility. Okay. Thank you, Vaag. Winam.
Hello, Neil. My name is Martin Olo from Fab Lab Winam Kisumu. I attended Fab Academy 2016 and thereafter started a move on how to create a Fab Lab. Eventually, in 2018 June, we got incubated by one company called Africa Stocking, which is based in the capital city of Nairobi, but works in many African countries. So this is going to be the very first Fab Academy that we are going to host, and we are lucky to have 5 students. We have Bramwell, we have Yoko, we have Charles, we have Derek, and we have Cedric, who is actually coming from Congo to attend the classes here. We actually
Tell me again, where is Winam? Where is Winam? Where are you
Winam is located in Kisumu, which is the western part of Kenya. Actually, it's few distance from Arrow Center. You remember Arrow Fab Lab?
Yes.
Yeah.
Okay,
So,
all right. Right. So, got it.
Thank you.
Okay, good. Right, now I'm connecting Arup and Winam and Western Kenya. Okay, good. I'm delighted you're joining. That's great. Welcome.
Yeah, and just a minute. Our instructor is Felicity Major, who is doing her second time in instruction, and that is very good for us.
Good. Yeah, I'm glad she's doing that for you.
Hello. To see you again.
Good. And are you in Nairobi, Felicity?
Yes, we are coordinating Nairobi, Kisumu.
Yeah.
Tomorrow we'll be in Kisumu. Oh, this is Charles.
Okay.
I'm also Charles. I'm with the Fab Lab Winam, but I'm actually streaming this from Nairobi.
Okay, great. Okay, good to see you. Yaka. ZOI. Echo Fab.
Hello, can you hear me?
Yes.
Yes, okay. We are ZOI, or SOI. It's a Fab Lab that is inside of a company, and this company is inside of a community creative place. So we have a lot of creatives like architects, designers, industrial designers, graphical designers, etc. And we also been growing a lot. Last year we started this Fab Lab here in Quito, in Ecuador, in the center of the world. And we started in 50 square meters, like really small. And then we start growing a lot. As parallel development, as Fab Academy show us. So we now have 3 places in the city. One is from creatives, and another from artists, and then another from programmers. So it is growing a lot.
Good. Okay. Thank you, Zoe. Echo Fab.
Yeah. New?
Yep.
You are. So hello everybody, we are EcoFab. We are a Fab Lab based in Montreal, so in the province of Quebec in Canada. The lab came from a non-lucrative organization in which we strongly emphasize on the democratization of new technology by different via. It's the 4th year we're giving the Fab Academy program. This year I will be the local instructor. We have 6 new students and 1 continuing student. One of them is a remote student, so hello for me. Apart from that, we are responsible for the 2020 hosting of the Fab Lab 16. So we'll see you there. Sure. And that's it.
Okay. Good. Thank you, Montreal. Did I miss anybody?
Here in Munich, Fab Lab Erfindergarten.
Okay. Erfindergarten. Go ahead, Andreas.
Yes, so Erfindergarten means inventor garden in German or in English, and the lab exists 2.5 years. We have been doing Fab Academy for the 3rd year, but still have no graduates. So we hope this year Kenny will graduate, and Seb as well, Joseph. Our lab is not inside any university. It's just me, but I'm now need to really create a non-profit, and I'm hopefully, so my focus is teenage next year, and hopefully can get the support from the city, because realizing a Fab Lab by your own is very difficult.
Okay. And in fact, one of my favorite parts of this is this diversity, but you should all use each other. Each of you is a good example for somebody else for what a Fab Lab can be. So you can use each other as case studies and examples. Okay, so good to see you, Andreas. I see Suriname join now. Go ahead, Suriname.
Okay. Yes, we're so happy to be able to participate. The good news is it's not just Suriname. We're working together with French Guyana, and we got a lot of support from the Fab Academy. So thank you so much, Neil and Jana and Carrie, that this year we can finally participate. We're gonna be traveling a lot between Paramaribo and French Guyana, but we're really excited, and we have a group of 8 people this year. So next year, hopefully there will be. So thank you so much.
Good.
Also,
Welcome. Glad you could join.
yeah, we're a government organization, the Ministry of Trade, Industry of Tourism, coordinating this. But we're working together with five scale-ups in Suriname and with Kapla for manufacturing Guyana, as well as with Provita, which is connected to a senior high school here, vocational school. So we're pulling our resources together so we can do it.
Great, that's great. One suggestion for the future, talk to the microphone, not the screen. You should talk to the microphone we can hear you, but for the audio to be better, talk to the microphone rather than the screen. Okay, welcome, glad you could join Suriname. Okay, did I miss anybody else?
Yes, hi, Digiscope Paris.
Go ahead.
Okay, we're just located just south of Paris at the University of Paris-Saclay, and we're here with Theo and Remy, and we're very excited to participate this year.
Good. Glad you're able to join.
Thank you.
I'll be in Paris in a few weeks, and Roman will let you know. We're planning a time to get together in the Paris area.
Oh, that sounds great. We're looking forward.
Good. Good. Anybody remaining? Okay. If not, that's what Fab Academy is. That's what we're going to be doing. Recitations will be every other week, so not this week. This week, all I want you to do is think about a final project and browse through the history of final projects. Then next week we'll start on the random review, where we'll meet people much more slowly. We'll meet students and talk about project ideas. And then in the class next week, I'm going to cover web development tools as one of the core things. And then one of the most important skills is distributed version control that will be used to managing the content in the class and documenting it, a core skill throughout the semester. And so now we're up to one of my favorite parts of Fab Academy, which is at the end of class, we have a global goodbye. And so with this, that's the end of class, and I applaud all of you, and we say everybody on the planet gets to say goodbye to everybody. So bye-bye, and see you in a week. Bye-bye, and see you in a week.
Bye-bye. Bye-bye.
Iban pasando. ¡Hijos de puta! Bye, 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 bye.
Goodbye.
Adiós, habla.
Goodbye.
Recording has stopped.
Goodbye. Goodbye.
Yes, and follow Martin.
Bye
Where
bye
is
bye.
that?
Bye bye.
Goodbye.
Take off the mask.
Look at all these guys, they're still messing around.
Bueno, a veces sí.
Oh,
Happens if you
63, 63 son los últimos 61. Nos quedamos hasta que salgamos.
Bye, everyone. See you.
Adiós, bye, Germán. Ya nos han dicho, ya nos ven.
Where the guys from Paris? Where the guys from Paris?
Ya nos han
Ja,
visto.
also was hier, also es ist so krass, was die hier alles
Let's go.
Hi, guys.
Hi,
I'm
how are
playing
you?
Fortnite and
Bye, guys.
in all the bandwidth.
Bye.
Hey, Frank.
Bye. Nice to see you.
This is Francesco talking, man.
From the beach Fab Lab. He was my Fab Lab instructor and the first one to become Fab Lab.
And you have a lot of fans.
Hey. What's everybody working on? Bye. Oh, it's muted. We muted it. Unmute us. Yeah, wait, I want to talk to him. See you guys next Wednesday. It was nice to see everybody.
Nice to see you.
Sometimes this code is not straightforward, so we like to make it all you have to have at least like 2 or 3 years of experience. Or you should have a very good achievement. So if you make, for instance, I made super good final project, and then you let me mentor it just the day after.
Hello, Dubai. Dubai, no. Dubai, hello.
Goodbye. He says goodbye or goodbye?
Andrea, sei still lì? Huh? I just saw you, so I said hello. Hello.
Hello. How are you doing in Germany? It's cold there?
Good. Figuring out my life, man. I need to really set up a proper. Now I'm realizing my lab is a hobby. I need to make a more like a non-profit or business. It's not a business.
Yeah, you can get into the class at between 9 and 9:30. Between 9 and 9:30, there's always someone you can say audio test, and you can. I can be there as well. But normally you find there's always someone you can say audio test.
Hey, Daniele.
Not after 9:30. 9:30, that meeting with the instructor starts. So from 9:30 to 10, don't do it. And anyway, we can even meet even before, just with me, to check it. And the easiest way would be to just use. Aspetta, che ho levato il.
Come stai, Saverio?
You have to do you have to use earphones, and you do.
Which one are you using so I don't use the same one? The third one would be the middle one. This one? Yes. Alright.
I just need to open it. But if I find it, you can get that.
Honestly, I thought for some reason I thought this was alright, now I'm gonna do it. There is something wrong with Google Classroom.
Yeah, maybe if you log in. Or I've saved it on internet stuff. But it's just so hard to order.
Oh, no, I got it.
Oh, I just found it. So
No,
no,
we
I
can go
didn't
through it.
find it.
I don't know. I don't know. It's just Excel.
I don't know. I don't know. Last time you just like magically found it.
Should we just stay in front of the camera
Because
and
I
be able to
already
do this?
have
I was already talking to him. Yeah, you're You actually talked to him.
Yeah,
and then they said goodbye. I was like, bye guys, nice to see you. And I was like, nice to see you. Well, yeah, I thought, how can they hear you? I took the mic.
Well, it
unmuted
means
it
that
and talked to him.
I've gotten past
Alright,
that.
now what, buddy?
At your age.
So select the thing you want to 3D print. Yeah, can you just tell me how to load it in and then I can probably do it from there? Oh. Where is it? It's right here. Okay, let's go file.
Sometimes it takes me things like.
Oh, you need to do it.
Look, there's nothing in my app.
Oh.
Ask me what?
Spray with water.
Okay, so. Oh, he's right here.
Here I am.
This thing is so crazy. Open first.
Here are the plates on top. Honest. It's not like mine. Yeah, I feel it. That's probably good. That helps us. You're supposed to do it before it. Skip it. Yeah, I'm over here.
Well, like sliced.
I'm sure it's just gonna. It's fine. Alright. Then. So it's on there. It's like recap.
But I've never been able to find it before.
Put connected. Then put PLA for a print.
Well, what size print are you doing?
It's like this big. This what or this far around and
Use
like
the red
that
one
big.
next to it, then you don't have to worry. It's not your finished product, don't worry about the color of it.
We'll just use a different printer.
Yeah. Use that printer, use that far end printer.
Alright.
Yeah, well, I told this thing on, sorry.
Mr. David, are we allowed to put the
Yeah, but it's not that simple.
Oh, I hope not, if we are, I gotta order more right now.
Yeah, there, I can't find
You know
it.
what the pliers are?
There were none in any of those drawers
Did
that are
you look up
labeled
on the back wall?
by all the supplies.
Top, on top.
And then you have to go.
It's already on
Oh,
top.
yes, I already have that set up.
You know what, I don't think I was gonna use.
Yeah, because mine wasn't loaded either.
I know, it's so weird. Like whoever made, somehow it's both Autodesk, but they just don't. Yeah, it's like a stack on top, but I would still order one. Like, there's a bunch of small ones, but there aren't that many big ones.
I will get that for you.
But now I want to use install slicers, I know I already have. Oh, I figured out it.
Yeah. Is it, what is it? Yeah, you can snip it. Are you connect, is the printer heated up though? What? You gotta heat it up first. Yeah. Oh wait, I gotta click home. What do I do after the normal thing? What do we preheat it to? 220 and 60?
For some reason, when I sliced it before, so I lost my file, which could have been a bad thing, but actually turned out to be a good thing because I just figured out a better way to do it. But now it's like sliced around because it wasn't like literally set.
So all farewell, goodbye. That is, is it hot? It's got a picture. Who wants to know how to put the PLA in the?
Okay, I shared with you right now, so you'll have it, but there's a workflow for you. If you go look at it in Google Classroom, I gave you an update on it. So what to do on the jam. So the first thing you want to do is let's get this hot.
Well, I believe this one's no longer jammed, actually.
Yeah, all right, so to fill it in frail, the first thing you still got to do is get it to it now. Now, once you have that, then you lift that up, push back, and then shove this through. See that? Then, once it changes to 10, and if you look at that iPad, I tell you how to replace this. Yeah. You're gonna set that to 10, you're gonna extrude it. If it doesn't extrude, stuff doesn't come out, all right, good, it's coming out nice and clean, it's ready to try it, okay?
Okay.
Fair enough?
Yep. Thank you. Extreme length, 10. Mr. Divick?
Yes.
Oh, no.
The mount, yeah, the mount extrude.
Oh, very nice. But it's still got one way that needs to be used.
No, don't do that. Just use it.
How fast this is. So now what? Don't make your mouse receive the crowd. Yeah. No. Did you extrude
How long
yet?
is yours taking?
Did you extrude yet?
Why isn't it?
What?
Wait, this is yours?
Yeah.
Because like mine says right here how long it should take.
See, yours still thinks says.
Yeah, it's true. I don't know if it's say.
I don't know. I'm just.
I got it. Okay, go to there. Go to. That's speed. Go to. That's not the right speed. It's
PLA what?
Polylight PLA.
Yeah, it is. Look. Polylight PLA. It was on it.
Oh, what's technical? And then for those. Do that one because it would be a weight meter.
So yours says the same thing as mine.
Yeah. It was just because you hadn't had the thing.
Yeah, mine's been chilling right here for a little bit. Oh yeah, I forgot it waits for some reason, and the temperature goes down. I know that's supposed to happen.
Should we have made everything at the home?
I already hung mine. Don't do it right now. Did you?
What's
hook
that?
it
What's your
before?
question, guys? Yeah, I did.
Yeah, you just have to hum it before.
Never.
Just bring it so you can have it on.
I can read during the noise. They usually pop around all this stuff.
Yeah. I don't know.
But I really say that's what they do. Like chocolate or something.
You can 3D print a 3D printer. So you can do it.
Not all of it.
No, not all of it. That's
Oh, that's kind of weird now.
Yeah. So, there fish. No, it's right. I promise. Or, I think you can board it. Mr. Dubik, typically how long does it take for it to start printing once you click start?
A few minutes. It's gonna cool down, then warm back up.
Alright.
It's gonna wait until it starts. can't leave until, and I'm serious on this, until you see it start
Oh, yeah.
sticking it down, so it doesn't just spill out.
We still have like 20 minutes, 15 minutes.
15 minutes.
Man, who's counting?
Yes, what's time? We think time is actually a distortion.
Time is relative.
Just think, we all might be part of somebody's simulation. What are, oh, 4 minutes.
Yeah.
Thank you very much, because I just got email.
They're going to, I was going at the same time.
All right, guys. It's 3 minutes. I still have a class for 10 minutes, so you sometime has class for.
That's wiping off. Make them red.
I'll come with you if you want, honestly.
It'll be done.
How long is yours?
2.5 hours.
What's what, did you divide one by 12, right, like, what is?
I think it's like calibrating color.
What, 0, 8, 8?
Last number all the corners.
I remember the OG 3D printers we had in here. The like circle one.
Yeah, no, you remember like the glass?
Yeah.
The big glass one, and then these things used to be glass, like the
Yeah,
trays.
I remember that.
With spray hairspray on them. Yeah, it is, dude.
What did you study with?
Have you stopped one to work then? Yeah, mine's not. Mine was ahead of yours. That's what he's nervous. What? Cool, yes, it is. That's gonna be solid. That's how it always starts. Do you not see it do that with mine? Look, see? You never seen this before?
No, I have, but I just not this in practice.
Yeah.
Yeah, space out the box as well.
Oh, did you
Travis,
design
where
it?
are you at on your thing now? Can you start now that you
There's a
filed?
bigger one I got all in it. Yeah, that's good.
What did you crop?
You're just hit cancel if there's stop print.
I'd give it a minute. Maybe it's just like that one piece, but if it doesn't line up after that, then you're gonna want to cancel it.
What if I try to pull that off?
No, because it's gonna be raised. It's supposed to be raised after that. You see what I'm saying? Like it's gonna be a tiny bit higher on the plate, so you might be probably not.
Yeah.
This is the moment of truth.
It may come together. I could probably like start snipping, clean it off after.
Well, that's what I'm saying. It depends if you can get a base down. This is your moment of truth. If you can get this up there, there you go. Yeah, you'll be fine. Yeah. Why? Dude, I don't know why mine turned out so much cleaner.
Maybe
It's a lot more
hairspray on it. No, that's that one.
I don't know. No, yeah, I sprayed this one too, but it's a lot more basic.
No, I just found
Oh,
it.
now it's doing. Oh wait, no, it's doing like the.
But I don't know where it came from. Oh, it's under Autodesk Web
Dude, mine's 4%.
Production, and then it's under Design.
No. Give me some.
Getting the like 4 minutes.
Nah, they were just like, oh my god.
See, like, look how clean of a print.
That's actually kind of fun.
This is the high definition print. That's so clean.
Well, you got a sample.
Oh yeah.
No, we need to do that. We gotta have some fun. Charlie and I always just do high five minutes.
No. How about like going to the bench? Whoever's on the bench has to do the handshake, and you just.
Yeah. We're running down the court. Because we'll be scoring a lot of points.
No, you're not. Why does everyone think our team's so bad?
Because you guys haven't won a game yet.
That's because we never tried. Okay. And we forfeited too. Most people just didn't want to go.
But you guys are strong for this one.
Oh, dude, the whole squad should go for this one.
Is it pass? Technically, is he strong?
Yeah, Paxton's good. He can shoot. And he played.
I've seen Paxton play.
He's decent. He played what's it called for a while?
Church league.
No.
We went 1-7 at YMCA.
AAU, there are two types of AAU. And you can tell pretty easily which type it is. It's either my dad providing money for me to be here, or I'm insane. You can tell pretty easily just looking at the team.
Fat.
Yeah, my dad.
We went 1-7 at YMCA. We were forced to be insane.
Dude, they were actually
some
like
teams
really
like
good teams. I was not ready for it.
I get dumped out.
One team
most nights.
put up like 35.
Yesterday.
We're like, alright. They all had like super.
They're like a legit team. Yeah.
But it's actually it saves itself, I think.
Yeah.
You're gonna have to do some surgery though.
Yeah, I'll do some samples.
Might get covered up by you.
No, that piece, that string in the middle.
Oh yeah,
That's nothing covering it. You're gonna have to do some surgery.
I was gonna send a track over there.
Yeah. Is this gonna be your final one?
But I can front. I can start to make. I made that one. The bigger one I got. No.
Mr. Dubik.
This one like doesn't have any.
Do you think this is enough for me to be able to leave it?
Let me see. Take a look. It actually is coming back. Yeah, I like that.
And so I end up with like.
Yeah.
I believe you go to the
Look at his mind.
Come on,
I'm literally scared.
How upset are we?
But this is the, I mean, worst comes to worst, we get out the saw where we only got that saw, so our mark. We're gonna try to find a little better saw to use mark up.
It's innocent you.
No, it always does that.
I know, but it's kind of funny.
I don't understand what the very wide part is for.
I think it's probably a test, yeah. Very, like, make sure it's the
complaining about it. Oh, yeah, the night they were using them. I don't wipe them off. I was like, oh, I hope it. You don't want to, I don't want to clean it.
It's a real struggle, real problem.
No, but I can see that working though, because people probably don't clean.
Yeah, that makes sense, yeah. And it'd be so easy just to stick it in.
So you stick it in, it like cleans it, then like puts it in a pile, right?
It like hangs it up. It's gonna be about.
Is it gonna be going? Oh, the mass gonna be going vertically?
Yeah, like this way. No, horizontally, but.
This is the mat.
If my hand's a mat, it's gonna be like this. It's about this long, and it's gonna be about that wide. The final one.
Gotta make sure it's like super user friendly.
Oh, it is. It's just gonna be like.
Put it in on a conveyor belt.
It's gonna be like there's not gonna be any like interface or anything.
You gotta, so it's like always spinning.
No, it's just gonna have, it has a sensor, so just put the mat in, it just kicks in. Kicks in. Yep.
Alright, come on. One more minute, folks. Good, I'm glad you feel that way. Go ahead, everybody have a great day. I gotta stop this and go over there.